and Advanced Technology. This is the first session of mini symposium with the topic about marine hazard and coastal degradation, subsession coastal hazard along the south coast of Java. On behalf of the committee, I am very pleased to join this virtual conference despite the challenge posed by the COVID-19 pandemic. I would like to thank all the invited speakers, presenter, and distinguished guests for taking time to participate in today's conference. So before we start this session, I would explain some rules. So please, participants are required to mute the audio during the presentation. Question could be delivered during the presentation or at discussion session in the chat box, or you can raise your hand reaction. You can ask the question both in Bahasa or English, and I will read your question in the chat box. For invited speaker, you will have 15-minute presentation and 5 minutes for question and answer. As a moderator, I want to remind to all presenters to please strictly stick to our time schedule and not to let any session overrun. For those who will do a live presentation, please kindly check the time monitor. Okay, so let's begin our symposium. First presentation will be delivered by Professor Dr. Eng Nining Sariningsih from Study Program of Oceanography ITB. The title of her presentation is Was Cyclone Seroja Associated with Marine Heat Wave in South Sea? Time is yours, Bu Nining, please.
Should I present directly in live or using
yes.
the video directly?
Oh, okay. Yes.
Directly.
Just a moment. Okay, Bu. So yes, I think Bu Nining already sent the video, so we will
I and
show
my
the video.
colleagues, okay. Dr. Aitaria, Erlin Beliana, from Research Group of Oceanography, want to say thank you for the opportunity to share our preliminary result on the development of tropical cyclone Seroja. As we know, the cyclone Seroja was a deadly tropical cyclone and lead to severe disaster impact, especially in Nusa Tenggara region. This cyclone caused extreme flooding and landslides, as well as killed almost 160 people. The cyclone started to develop in the South Sea with classification from tropical depression and tropical storm, and then moved to the Australia and became category 1 and 2 on the Saffir-Simpson scale. Several conditions are needed for a tropical cyclone to develop, such as warm sea temperature of at least 27 degrees Celsius and winds which force air to rise and form storm clouds. Regarding warm sea temperature, in this study we focus to investigate whether marine heat waves play a role on the development of the tropical cyclone Seroja in the South Sea. Marine heat waves is a discrete, prolonged, anomalously warm water event exceeded the seasonally varying 90 percentile threshold for at least 5 days. Previous studies have investigated the role of the marine heat waves on the development and evolution of tropical cyclone, such as study carried out by Nito et al. In the tropical North Atlantic. Based on 36 data of marine heat waves frequency, they found there is a strong correlation between the number of tropical cyclone in the tropical North Atlantic, particularly major hurricanes, and the number of marine heatwave days in the mean developing region. Years with higher numbers of hurricanes only happen when the mean developing regions experience marine heat waves of the order of hundreds days per season. This is our research motivation. We want to know what the cyclone Seroja associated with the marine heat waves in the South Sea. Here we use data about 10 years at one location in the South Sea as the cyclone Seroja developing region. The data are SST, wind, surface pressure, and also chlorophyll. The slide shows marine heat waves occurrences in the South Sea in the period of 2011 until 2021. The green line indicates climatology of SST. We see that the warm SST usually occurs in west, first transitional and second transitional monsoon. This seasonal SST is associated with the seasonal shortwave solar radiation in this region, which is located in the southern hemisphere. The red lines indicate the threshold value for determining the marine heat waves, whereas the blue line shows the threshold value for determining the marine cold spells event. The figures show that marine heat waves in the South Sea nearly all year round in 2016. This seems to be associated with the decaying phase of El Nino, the developing phase of La Nina, and negative Indian Ocean dipole. Meanwhile, in November and December 2020 and in January 2021, it is about 2.5 months before Cyclone Seroja event, the South Sea also experienced marine heat waves, which seems to be associated with La Nina event. In the next investigation, we focus on analyzing SST and marine heat waves characteristic in the period of January until March in 2016, 2020, and 2021, in which January until March are months before the occurrence of tropical cyclone Seroja. For additional information, this figure shows ENSO's impacts on global ocean carried out by Wang in 2019. Here we focus on the ENSO impact on Indian Ocean basin. When an El Nino event is developed and matures, a basin side warm Indian Ocean occur simultaneously or in the following spring. The basin side warming of the Indian Ocean quickly develops in the winter and peaks in the subsequent spring. These findings can be used to explain the warming of South Sea after the decaying phase of El Nino. These figures show marine heat waves and mean sea surface temperature anomaly in the South Sea for the period January until March in 2016, 2020, and 2021. It can be seen that year of 2016 experienced marine heat waves longer than in 2020 and 2021. It is about 40 days for 2016, 7 days in 2020, and 5 days in 2021. Moreover, the mean sea surface temperature anomaly in 2016 is also warmer than in 2020 and 2021. In this case, 2016 year did not cause the development of tropical cyclone over the South Sea. In fact, the tropical cyclone Seroja developed in 2021. It seems the development of the tropical cyclone Seroja was not strongly correlated with marine heat waves in the South Sea as the developing region. This figure shows mean sea surface temperature anomaly, mean surface pressure, and mean wind speed. Also for the period of January until March from 2011 until 2021. It can be seen that although the mean sea surface temperature anomaly in 2016 is warmer than in 2020 and 2021, the wind speed in 2016 was weaker than in 2020 and 2021. In this case, the wind speed in 2020 is stronger than that in 2016 and 2020. In addition, the largest number of days of wind speed greater than 5 meters per second occur in 2020. It is of about 37 days. Meanwhile, there are 13 days in 2016 and 33 days in 2020. Therefore, strong wind speed and duration seems to be more responsible for the development of the cyclone Seroja. In another perspective, this slide shows the cyclone impact on the development marine cold spells in the South Sea. These marine cold spells result from upwelling generated by Ekman pumping and atmospheric forcing during cyclone Seroja. It causes temperature declines and chlorophyll increase. The biological consequences of the occurrences of this upwelling phenomena, which carries cold and nutrient-rich deep water to the surface, in turn will also increase biological activities such as the abundance of fish stock. This slide shows Ekman pumping and upwelling before the cyclone Seroja occurrence on March 25th. The left figure is SST and the right one is Ekman velocity. Both figures are overlaid by wind speed. The bottom figures are time series of SST and Ekman velocity at one location in the South Sea. This is on March 31st, and this is during the development and evolution of Cyclone Seroja on April 3rd. It can be seen that in the South Sea, the Ekman velocity increase and the temperature decrease. This is for April 4th, when the Ekman velocity reached its maximum value. And this is for April 6th, when the SST velocity in the South Sea reached its maximum value, and the tropical cyclone Seroja already moved to the southern water of Sumba Island. This is our conclusion. Our preliminary study showed that the development of Cyclone Seroja was not strongly correlated with marine heat waves in the South Sea as the developing region. Anomalously strong wind speed which increased the evaporation of warm seawater in the South Sea in the transitional period in March and La Nina event seem to be more responsible for the development of the South Sea. This is our motivation.
Okay, Bu. So probably that is not affected by La Nina or El Nino, ya Bu ya. So it's more like by the heat wave on the South Sea.
Yeah, I mean the heat waves it can be caused by La Nina and negative Indian Ocean dipole mode. Yeah, and in this case, when the cyclone Seroja occur, this is La Nina condition, but the marine heat waves like in 2016, it almost occur all around in that year, but it not what is generate the tropical cyclone. So it's mean the marine heat waves in 2016 generated by La Nina and decaying of El Nino phase and also negative Indian Ocean. But if the wind speed is not stronger enough, so the tropical cyclone will be not generated. This is our findings here.
Thank you very much, Bu. Very clear explanation. So is there any question from other participants? Okay, So I think, thank you very much, Bu Nining, again for the presentation. So if other participant has a question, you can chat in the chat box. Okay, now we go to the second presentation. So the second presentation will be presented by Dr. Eng Hamzah Latif, MSc. He is also from study program of Oceanography ITD. The title of his presentation is Implementation of Impact Chain to Analyze the Risk of Coastal Flood in Indonesia by using full-pass method. Pak Hamzah, please, time is yours.
Thank you, Bu Alin. Can you hear me?
Yes, Pak, clearly, Pak.
So, good morning, dear of impact chain to analyze risk level for coastal flood in Indonesia by using full-pass method. Full-pass is a vulnerability and risk pluralistic estimation system. Is a tool for estimating vulnerability and risk of climate change, which based on the
So I think there is some problem on the connection. Maybe we are waiting for Pak Hamzah to joining the room again. Please wait. Thank you. So, dear participant, we are sorry about the connection. So, please wait for a moment.
I'm so sorry. I have problem with my internet connection. Okay, I will upload again. So, I'm sorry once again. This full piece is visualization cause of effect relationship of risk climate change and quantify the risk of climate change on the web-based GIS. So the user can use full piece by evidence-based policy making tool and then prioritize the area for adaptation measure quantitatively and then discuss expert judge on way to indicators and also add data and improve full pace by themselves. So the full pace actually was applied in Indonesia under collaboration between Ministry of Environment Japan and Econsal Japan with the Center for Climate Change (ITB) in 2020 and 2021. Regarding to the condition of Indonesia, which has a very long coastline, so that's one research focus on coastal flood. This the step of risk assessment of climate change based on the guidebook of GIZ, and then developed by 9 modules. First is preparing the risk assessment and developing impact chain, identifying and selecting indicators for risk component, from data acquisition to risk assessment, normalize the indicator data, weighting and aggregating indicators, aggregating risk component to risk, presenting and interpreting outcomes of risk assessment, and identifying adaptation option. This is the module. And then first is preparing the risk assessment. So we know this risk concept of IPCC. We consider the hazard, vulnerability, exposure, and then we can use this formulation. And then we try to identify the component of each the indicator of each component. For example, for coastal flood, we try to identify the temporary inundation at coastal area caused by tides, global sea level rise, La Nina, storm surge, flood from inland, mean sea level variation, monthly variation, and also sea waves. And then this hazard component. And other component is exposure. We consider population, infrastructure, road and harbor, capital city or province on district, this as a proxy, and also sensitivity component consists of coastal slope erosion, ratio of village and some settlement on the coastal area, ratio of village according to slum settlement, vulnerable population, ratio of poor people. And other is adaptive capacity. Here we consider number of seawall, proportion of city government that have disaster risk reduction strategy document. And then this is the identification of the component. Here we can see the component of hazard and this component of exposure, and then this the impact, and this the vulnerability as mentioned before. And then from this analysis we can from this step we can analyze the loss of life, economical loss at coastal flood and other. So this data, you can see the circle here. This data obtained from numerical simulation, research, and government database, and also some data are not complete. So we just consider the available data. So you can see here the red cross here. It's been the data is not available. And then identifying and selecting indicator for risk component. So we try to collect data. First is data on land or terrain and data from marine area. And then this point, we pick up the data from marine area, and this the coastal area along Indonesia. And then this the coastal hazard component, as mentioned before, the tidal range, permanent mean sea level, monthly mean sea level, global sea level rise, and so storm surge, flood from inland, and wave. And then we collect data from previous study like this. And also the exposure component consists of coastal population, number of capital city in province, number of capital city district, and then next is sensitivity. We consider the coastal slope, ratio of coastal erosion. So this is the data, but coastal settlement and poor people are not available. And then adaptive capacity, we try to collect the coastal structure along the shoreline for each provincial, and also the document, disaster risk reduction document. So we combine all the data and try to figure out the level of risk for each provincial level. And then this the weighting and aggregation indicator. So you can see here the hazard element like mean sea level, highest high water level, sea level rise, La Nina, storm surge, flood from inland, and waves and other exposure. So this city for province, capital city of district, port, harbor, and road. You can see here, and this the sensitivity, coastal slope, coastal erosion, coastal settlement, and coastal poor. And this the disaster risk reduction document. And you can see here we define as hazard, and this we define as exposure and also vulnerability, and we combine all, and then we can find the risk. So this weighting based on expert adjustment. So we discuss a lot about this, and then we can put the weighting for each component. And the next is the hazard map. From the analysis and the weighting of indicator, and we integrated all the component, and then we found here hazard map, and then we normalize this hazard map like the right figure. And also we have the frequencies of hazard data distribution for each province in Indonesia. And then this the exposure map, same also method before, and then we found here the exposure data distribution along the coastline of Indonesia, and this the normalize of the exposure map. And another is vulnerability map. We also have vulnerability map like this, and this the normalization of vulnerability map. And then aggregation of the hazard, exposure, and vulnerability, we can find the risk map like this. This risk map of coastline Indonesia, and also this normalization of risk map. And then from this data, we can analyze all by the web GIS, and then this actually available in server in Japan in this data. The next is this risk profile chart of the risk. So from here we can see this for West Sumatra. We can see this the blue is hazard, yellow is exposure, white is the vulnerability, and red is risk. And this we can see for each province which one is dominant. Is it dominant of hazard or dominant of vulnerability or exposure? And then from this we can analyze which one province will be prioritized for for adapting, for acting adaptation. And then the last is identifying adaptation measures. This general approach, so there are several efforts can be done to reduce coastal flood hazard, like constructing seawall, estuary dam, polder, retaining pond, and water pump, maintain river embankment, river flow by dredging, improving capacity of drainage, and also provide and educate freshwater and infiltrating well by means to reduce groundwater extraction and reducing land subsidence, maintain sand dune, coastal vegetation, and mangrove. And adaptation effort can be carried out by government and stakeholders by review spatial planning that can accommodate coastal flood by change the SOP from the planning, implementation up to maintain stage, monitoring and evaluate. For instance, increase elevation of road that affected by coastal flooding and construction of drainage system. And other adaptation effort are carried out by individually and communities that affected by coastal flooding, namely by raising the floor of the house, build of house with 2 stories or 4 stories building, build embankment around the house, planting mangrove and coastal vegetation, and other. I think that's all. Thank you very much for your kind attention. I give back to Bu Alin.
Okay, thank you very much, Pak Hamzah, for a very interesting presentation. So actually, yesterday I tried to find what is full paste method, and it is show the fox, so not showing. So that is the abbreviation. So I welcome everyone. If you have a question to Pak Hamzah. Okay. So while we're waiting, maybe I have some question, Pak. So my question is, I think around 3 days ago, Joe Biden, the president of the United States, gave a speech predicted that Jakarta would be in danger of sinking in 10 years. My question is he exaggerate the issues? And also from your analysis, which area actually face the greatest danger in the north part of Java? Thank you.
Yeah, I think of course along the you mean along the North Java?
Yes, Pak. Yes, Pak. Especially yes, along the North Java, Pak.
Okay. I think from the oceanographic parameter point of view, I think the sea level rise is same, maybe 0.7 centimeter per year, and then we need to consider more about the monthly mean sea level change and also the tidal range, and of course the extreme event like storm surge. Even the storm surge occur in South China Sea, but the effect of the low pressure can be generate sea level rise, but the main issue actually the groundwater extraction, like in North Jakarta and other in Pekalongan. I think because there are many batik industry there, so they extract the groundwater to support the industry. Especially for Jakarta, for example, if the water fresh cannot supply from the inland, so the hotel and other industry there, they must be extract from the groundwater, and also consolidation of soil due to the big or the large building, and can be like compaction of the land. I think this, the issue, and other is because the sea level rise, and so make the slope of water from inland to the sea become more mild, and the current can river current become decline, and then the sedimentation, so the capacity of river also the capacity of river also decline, make the coastal flooding. I think that's all, Walin.
Thank you very much, Pak Hamzah, for your answer. So actually, we still have around 2 minutes for question. So maybe we are wait. Okay. So there, Muhammad Farid. Yes, please. You can. Okay. Sorry. You can ask your question now.
Okay. Thank you, Ms. Chairman. Good morning, everyone. Pak Hamzah, thank you very much for sharing very interesting and important presentation regarding coastal flood. I think my question is related to what already mentioned by Ibu Karina, Bu Karina, Ms. Chairman. It is related to the hot topic that has been discussed widely about the sinking of several cities in Indonesia due to coastal flood. And I think the important factor that has been discussed, that it is related to the significant land subsidence rate, Pak. Yes. Perhaps my question is, are there any possibilities to include the land subsidence rate, for example, in the coastal risk assessment? Maybe, for example, we include the land subsidence rate into vulnerability factor, or maybe in hazard parameter, or maybe you have any opinion, Pak Hamzah. I think that's all. Thank you, Pak Hamzah.
Thank you, Pak Farid. Actually, for the micro analysis like Jakarta, we have been include the land subsidence, and we presented 2016 in Bangkok with case study of Jakarta. But in this case, because we study along the shoreline in Indonesia, so we didn't consider about the land subsidence. But for the case of, we have also project support by the natural conservation for Semarang City. We also consider the land subsidence because the Semarang City has very, very high rapid land subsidence. I think it's very important to consider the land subsidence. For example, the sea level rise actually 0.7 centimeter per year, but the land subsidence could be 8 centimeter, maybe more than 10 centimeter per year. So it's very important to consider. Thank you, Pak Farid.
Thank you, Pak Hamzah. Thank you, Mr. Chairman.
Thank you for your question, Pak Farid, and also thank you for your presentation, Pak Hamzah. Because time is limited, now we are moving to the third presentation that will delivered by Insinyur Harkunti Pertiwi Rahayu, PhD. She is a faculty member from ITB and also active as member of National Research Council, chair of TC on Environment and Disaster, Chair of Working Group 1 of UNESCO IOC Indian Ocean Tsunami Warning and Mitigation System. The title of our presentation is Increasing Business Resilience of Tourism Area in Pangandaran. Time is your, Bu.
Okay, oops. Yeah, thank you, Ibu Karina, Mbak Alin, for your moderating. So let me share my screen. Okay, thank you. Hopefully it can be seen already, right? Yeah. I would like to say my sincere gratitude to the committee of this international conference on maritime science and advanced technology for inviting me again, for this third program of the international conference. And it's really happy for me to share what I have been done and have been doing so far in these past 2 years after the last meeting in Makassar. And then for my presentation, I mentioned by Ibu Karina, Mbak Alin, is related with this increasing business resilience of Pangandaran tourism industry from the perspective of tsunami disaster risk reduction. So I might be sharing from totally different with what has been presented by Ibu Nining and Pak Hamzah. So because this is also showing a strong collaboration between all the stakeholders or multidiscipline in ITB. That's why we need to support each other. So to remind as the beginning of my presentation, I would like a little bit to remind regarding 2006 Pangandaran tsunami and their impact into environment and business. So I would not to explain this in further. I believe everybody in this room already familiar what is the impact of tsunami 2006 in the Pangandaran region, because everybody understand, because this is a very rare tsunami. Not many people can felt the shaking, but eventually within 3 minutes, within few minutes, tsunami has hit this area, which is that time is become our priority of the tourism industry. And then the DRR situation actually impacted by tsunami 2006, that in that time, the Pangandaran Regency was still new, a brand new Regency, which is become a regional expansion of Ciamis Regency, where the capital itself is not in Pangandaran, but still in Ciamis. That's why a lot of difficulty in response, especially, and then also in the evacuate the people when they heard also some information or rumoring about the potential tsunami. And then the position of local disaster management organization has not established for sure during that time because of the situation. This make the position of the response itself is become very bad. And access to the Pangandaran eventually after the tsunami, especially on the recovery and reconstruction, it takes about 6 months to 1 year. And also there is a lot of problem in lifeline, how the lifeline and also all the critical facility has been bounced back to perform in the not normal situation. It takes sometimes they can perform. Not only that, for example, the port, the hotel, and other things. The most important here that we identified during our study, actually there is also a lot of the transfer ownership in the hotel, because the hotel has been collapsed and they become bankrupt. They cannot rebuild again the hotel, for example, Hotel Menara Laut. And also there is other issue that has been highlighted, impact from the tsunami 2006 into the business of tourism industry. And then we understand here, I explained before, that the business, you can see here, talking on the capital itself, there is also shifting on the position of the capital. Before tsunami, the capital mostly owned by the micro and then a small, medium, or large enterprises. Actually, they have their own capital, bank loan, or family or relative loan. Due to the tsunami, actually, there is not much support from the family or relative loan because some of them also suffering from the tsunami. So they rely on the government loan, accept their own capital on bank loan. And this is also very important. There is a lot of the changes in the business segment from the craftsmen into the sellers. So this is because they do not need in production the raw material. And then this is the situation that we found post on the tsunami 2006, which is hit on the area of the tourism industry. And then in these past few years, after the tsunami has occurred, business back as usual. You can see here, from 2010 to 2025, this National Tourism Master Plan, that Pangandaran has been designated, become the super destination for the tourism. And you can see here how the Pangandaran can support not only as the area for tourism, but also for the economic growth in the region, not only Pangandaran, but also to the whole of West Java and the national. As we can see on the social and economic growth itself, there are, you can see on the left side here figure, you can see that accommodation and then amenities, also transportation, and then trading took almost the biggest portion of the economic structure. This is also shown that this is supporting that the tourism industry is become the prime mover for the economic development in Pangandaran. And you can see here before COVID-19, the increased growth of the economic in Pangandaran can be seen in this figure. And then the situation, because of that situation, is really challenged us to do more in-depth research. How is their DRR-based tourism business resilient can be measured, and how could we do to increase the situation or their business resiliency impact? So this is, I would like to highlight here a kind of little bit theory, why we need to do this DRR-based business resilient. Because if you're talking in the every disaster impact, for example, in 2006 tsunami, that the smaller business suffer the most, and then the smaller and then the medium also they suffer. But the big business, they don't have much because they have a lot of alternative business. So if you are talking about this business resilience, which is based on the disaster risk reduction, this is because very important. If you can see here, the definition based on the government regulation, that tourism actually has composed of many activity on the tourist, which is supporting by people and then the business and then government, national government, as well as the local government. So this is showing the importance of this increasing the business resilience will increase also the disaster risk reduction master plan in the city. And also we are talking on the sustainable development plan from the city itself. So to approach our research, that we are using two elements here. The first two element is two approach. First, we are using the element of coastal community resilience, which consists of 8 parameters here: the governance, society and economy, coastal resource management, land use and structural design, risk knowledge, warning evacuation, emergency response, disaster recovery, which is variable here, consists of several indicators that we are using to measure at the field. And also we combine those approaches with the basic concept of the tourism development. That tourism development we can understand here can consist of 5 aspects. First, we need to see the attraction, the amenities, the accommodation, accessibility, as well as the auxiliary. So by integrating these two approaches, we try to identify what is the level of the business resilience in Pangandaran. Looking at the point of the tourist attraction, so we focus our study in the coastal area where all of this tourist coastal attraction for the tourist area is we become our focus. So based on our study, we identify here from our observation, there is on the preparedness point of view, tsunami evacuation, shelter, and signage has been there, but the response of the community and tourists is very rare. I mean, it's a very, very amazing. And also in the situation of not all the evacuation signage, also in well-maintained or following the standard. And also you can see here, the shelter itself is the maintenance and also the knowledge of community is not there. And then there is many other issue also. And then, for example, tsunami evacuation shelter. So I don't want to explain a lot because time is limited, but I would like to focus on our finding on the disaster-based business resilience in Pangandaran. Based on our framework of the assessment, we can identify, I just give you 2 examples here from the accommodation business enterprise that we identify here. More than, like 2 groups, they have more than 50% respondent. They understand on the importance of their asset and also about their building following the regulation. But you can see here, there is also many indicators that has not been fulfilled by the accommodation business enterprise. For example, the hotel and then the like the small hotel and so on. And then also from the amenity, for example, the restaurant or the street hawkers and so on, we identify here, there's very interesting. even though it's not much compared to the accommodation business enterprise, but we can see here they are more, the identification of their resilience can be seen here in several aspects. So I will accommodate all of this aspect because time is limited. That the performance of the business resilience based on the disaster risk reduction as well as the tourism development perspective, we can see here for the Pangandaran business, the governance is taking still the highest compared to the average, and also the warning and evacuation, because I have been sharing before that it is well established even though the maintenance is low. And then, but other aspect here, for example, society, coastal, and disaster recovery is below. So to point out here, just so we can understand this is the resilience is very important, is very low. In total, only 33.551%, meaning this is the modality of this business in the area of tourism industry. But because this is lower than 50%, so we need to increase. Otherwise, if the big tsunami occur again, so definitely all the business will be collapsed without understanding this. So actually, we have another recommendation based on the research, but I just share about 1 or 2 recommendations. Here is how we increase business resilience based on the spatial and land use planning. We adopt of the information that we gain on how the Japan has mandatory for the all coastal area to have reformation on the land use and spatial planning. For example, how the red zone area, what kind of building and what is the facility that can be in place in red zone area. So no house allowed and office laboratory are permitted, but with the certain restriction, there should be tsunami evacuation places. What about the yellow zone? So area which is raised and reinforced, houses allowed. Otherwise, the housing should move to the safe area. But Japan, maybe Baalin knows very much now. Japan, they have a lot of money. They can do like this. But for us, it's really impossible. We try to adapt this into the very, what we call here, highest economic region in Pangandaran area. So we can see here the red zone and the yellow zone. There is a lot of critical facility and important in terms of economic business here. What should we do? We cannot just adapt from for example, the well-developed country to rearrange or reform the land use or spatial planning. So what we recommend here is try to integrate the situation. It's impossible to move out all of this area and then relocate to other places, but we try to live harmony with the tsunami by integrating some of the idea. For example, this area is full with hotel and full with amenities and full with the tourist attractions. So there is a mandatory in this area, they should provide tsunami vertical evacuation. And then also they should have updated tsunami evacuation route and other things. So I'm sorry, still like in Bahasa here, but definitely this zone can be defined into the block plan and the principal block plan, and then what kind of activity are allowed in the red zone and the yellow zone as well as on the green zone. So this is what we found where how we can increase the business resilience in the Pangandaran region. So I think this is my last slide. Oops. Thank you very much. Sorry, one more, Ibu Alin. So learning from that, because like, for example, if you are learning in this region, there is a lot of hotel in the red zone area. So if we can adopt the best practice from Sanur Bali, that based on our research back 2017, there is a Bali Tsunami Ready recognition. So Bali Tsunami Ready Hotel recognition, which is like we identified there is more than 10 hotel in the Sanur region, from the 3-star until 5-star, they are having this recognition. So the most important that we found during our research back 2016, 17, in line to strengthen what our finding in Pangandaran area, that 100% of the guests who are staying in the Tsunami Rodu Hotel, they mentioned they would like definitely come back to the hotel because of feel secure and safe. And then to the guests who are staying in the non-tsunami ready hotel, almost 99%, they said they will not come back to stay in the hotel. They will prefer to go to the tsunami ready hotel. And maybe everybody remember during IMF meeting, there is a kind of panic that the organizing committee from the IMF, they are first what they are checking the readiness of the hotel toward the tsunami, as well as how they can receive the warning and so on. So this is a big message that all of this business, especially related in the tourism area in terms of accommodation, need to consider this not only from the spatial planning, but also strengthening the element of the business itself. Thank you, Ibu Alin. I return to you.
Okay, thank you very much for the very interesting presentation from Ibu Harakunti. So we are welcome for participant. You can raise your hand or type your question in the chat box. So while we are waiting, I also have question to Ibu Harakunti. Okay. So I remember in the past event in Tsunami Krakatau, one of the biggest casualty is from tourists. Is there any strategy charged to the business player to provide evacuation plan to the tourists? And could you explain more about what is the Tsunami Ready Hotel?
Okay, thank you, Ibu Alin. Yeah, because one of the most important element in the tourism industry is accommodation beside amenity. We understand during the Sunda Strait tsunami back 2018 on the December, most of the huge casualty or the death toll is coming from the tourists because they don't know, even though actually there is a lot of intervention that has been in place in this area related of the tsunami disaster risk reduction. Based on our research during that time with Pak Hamzah, I think Ibu Alin also went there with us, right? Yeah, that we found that the what you call the survivor during tsunami because they see the tsunami signage. But however, the development of this area is not like it's in Bali because, for example, the hotel doesn't have any mandatory or have the recognition on the tsunami ready hotel because they don't provide the tsunami shelter. They don't provide significant or sufficient tsunami signage. So, for example, in the I forgot the one of the resort here when the band was performing, and then a lot of people died because the staff of the hotel doesn't understand, didn't warn the people, something like this. So back to the tsunami ready hotel, actually there is a lot of parameter almost similar with the tsunami ready village, but this is upscale to the hotel. So there is other parameter that has to be measured in the hotel. For example, the readiness of the staff, and then the readiness of the hotel to provide tsunami shelter, and then how the hotel can have link on the tsunami warning system, and also how the hotel can have frequent practice of drill, not only to the guests, but mostly for the staff and also for the community surrounding. So this is part of collaboration between the business and the community and vice versa. So hopefully answer your question, Ibu Alin. Thank you.
Okay. Thank you very much for a very clearly explanation, Bu. So because of our limited time, I think we have to move to other presentation. But for other participants, if you still have a question, please just chat in the chatting box. Okay, the last but not least presentation from the invited speaker will be presented by Dr. Irwan Mailano, MSc. He is the Dean Faculty of Earth Science and Technology from ITB. So his presentation title is Lesson Learned from the Palu Earthquake and its implication for research on earthquake hazard in Indonesia. Pak Irwan, time is yours.
Baik, selamat pagi menjelang siang Bapak Ibu sekalian. Good morning everyone. Thank you for inviting me to this exciting and important international conference. So today, I'd like to continue the discussion that has been explained in detail by Ibu Harkunti and also Pak Hamzah. And today I will bring you to the eastern part of Indonesia, to Palu. And I'd like to share with you the lesson that we can learn from the Palu earthquakes and its implication for research on earthquake hazard in Indonesia, especially for Java Islands. I have the 15 minutes and I'll try to make my presentation faster. But just to make sure that if I have internet connections problems, and this is the conclusions of my talk today. So I have 4 conclusions. The first conclusions, we need to start with a good definitions of earthquake source. So we need to have detailed informations on maximum magnitude of the earthquake, the return period of the earthquakes, and also the locations, the dimension of the earthquake. So we need to focus our research on these earthquake source definitions. And after that, we need to continue with an updated seismic hazard maps. I will explain later on why this updated seismic hazard map is very important. And after that, we continue with the earthquake risk. And finally, we need to have a good mitigation measure, including the warning system, building code, and etc. The thing that has been explained in a very good ways by Ibu Harkunti. My presentation today will be divided into 4 different parts. The first part is I would like to share with you the information related with the recent earthquake in Indonesia, especially in the eastern part of Indonesia, and continue with the recent conditions of seismic hazard map of Indonesia, and then followed by explanations on lesson from Palu earthquakes. And after that, I'm going to conclude my presentation with discussions. I just want to give you a brief overview why studying disaster mitigation is very important for a country like Indonesia. Because at least for the last 16 years, this is the data that we collected from 2000 until 2016, Indonesia suffer annually about 22 trillions. So every year, the Indonesian government need to spend about 1.6 billion US dollars to respond every disaster. And the number one, the most frequent disaster is the earthquakes in terms of economic loss, in terms of direct economic loss. If we calculate indirect economic loss, maybe the number will be double or maybe triples. So earthquakes contributes about 7.5 trillion every year. And after that, followed by forest fires, flood, tsunami, and so on and so on. And especially in the last 3 years, our country suffered at least 4 major earthquakes. It started with July to August 2018 Lombok earthquakes, and a month after we have Palu earthquakes with magnitude 7.4. And after that, we have another big earthquakes, Ambon earthquakes, magnitude 6.5. And beginning of this year, we have another big earthquake, 6.2 in Majene. And the number of casualties of those big earthquakes are more than 2,800. And the economic loss is about 8.5 million US dollar. And if you take a look, the publication seismic hazard map was in 1966, and this map updated 4 years later, the Indonesian in the year of 1970, and after that, we need to wait for about 13 years to update into the 1983 Indonesian standard for design of earthquakes resistance building. And the 1983 now widely used in Indonesia, since at the time is oil booming period in Indonesia. So we build so many critical infrastructure, including school, bridge, and many important infrastructure during the periods. And it is very interesting to see that if you take a look this seismic hazard map, this seismic hazard map put a very serious considerations into the area of the subduction zone, but only a little intentions giving to the has been given to the strike slip fault, the inland fault. So if you are talking about the possibility of having big earthquakes, inland big earthquake in Java, for example, so this map at the time not considers the, for example, Opak Fault or Baribis Fault, even Sumatran Fault Zone. So I think that's the reason why so many infrastructures collapse due to the earthquakes, especially the school. So many school in Indonesia built during the Inpres period, Instruksi Presiden period, elementary school, junior high school, and senior high school, even university. And then this map updated by the 2002 seismic hazard map, but still this map also doesn't consider the inland active fault. And until 2010, this is the first seismic hazard map that really consider an active fault, inland active fault, including Paru-Koro fault, Sumatran fault zone, and also inland active fault in Papua. And also 2 years ago, 2019, we just published a new Indonesian seismic hazard map. The seismic hazard map produced in 2017, but become a national standard in 2019. But still, during the periods of 2019, when we published our maps, until today, several big earthquakes occurred, and we think we need to update a new seismic hazard map based on a recent finding, especially on the finding on the seismic source, not only along the subduction zone, but also the inland active fault. And this is several active faults in Indonesia. So we successfully update the numbers of active faults from the 2010 seismic hazard map into 2017 seismic hazard map. So the numbers of active fault increase doubles or maybe triples. And let's continue with the lesson that we can learn from the Palu earthquake. Why Palu earthquake is very important? Because this is the first earthquakes that produce the multi-hazard effects, not only the ground shaking, the ruptures, but also this earthquake produced tsunami, coastal slope failures, liquefations, and last year we surveyed more than almost 400 locations, so showing by green dots, red dots, and purple dots. It's the area that we surveyed last year. Actually, this year we need to go to the Palu again, but due to the pandemic, we need to cancel our trips. But we found a very interesting finding during the survey. For example, our findings are the first 3 days, the power went out completely. So you may imagine for 3 days, we don't have any electricity. And for the first week of electricity, only 65% recover, and after 2 weeks, 90% recovers. Damage to the water distributions, disruptions of gasoline distribution, and 60 ATM are experiencing problem. So most of the people at the time has no electricity, no water, no gasoline, and no money. So that's a very serious problem. And it is very interesting to understand that in terms of the tectonics, many scientists already published papers about Palu-Koro fault. The first paper that published regarding this fault was in 1977. And after that, several papers already explain the hazard of this area. And for example, one of the researchers in our group, Ibu Dina, mentions that this fault produced a slip rate about 40 millimeter per year, one of the fastest slip rate in Indonesia. Maybe we can compare it with the one of the fault in Papua, Tarera Aiduna fault. So it is this is one of the fastest active fault in Indonesia. And then and then based on our calculations, the slip deficits of this fault is about 2 meters, and it is already accumulated since 1968. So the next earthquakes, if we try to do the earthquake potential calculations, is about 50 years from the 1968, and if we can easily calculate that 2018 will be the next earthquake based on these simple calculations. But this kind of information is very hard to be part of this decision-making process in the national and the local governments. And then after the earthquakes, it is the result of our survey. So we found the rupture length is about 130 kilometers, and the rupture duration is about 25 to 30 seconds. This is one of the fastest rupture durations. So the average rupture velocity is about 4.5 kilometers per second. But this earthquake produced the average rupture velocity for the normal earthquake is about 2.5 kilometers per second, but this earthquake produced 2 times faster than the normal earthquakes. So the rupture alone might produce the tsunami. Maybe also in addition to that, we found also an evidence of submarine landslide. And also we found a very significant surface ruptures and offset more than 0.5 meters. Some of them reach more than 5 meters, not only in horizontal, but also we find the vertical offset. And based on the geodetic data, we analyzed one of the geodetic stations located in 200 kilometers to the north of the Palu. And we can clearly see this is a very clear offset, co-seismic offset due to the earthquakes. And even the station is quite far at 200 kilometers. And if we plot all the offset, we found a very interesting evidence of the heterogeneity of the slip. So this is become an input for the next updating of the seismic hazard. So usually we assume that the slip is homogeneous, but based on our finding, we found that the slip actually is quite heterogeneous. So we probably the slip in the north is faster compared to the slip in the south. And also we try to estimate the magnitude based on the GPS data. We calculate our GPS station using the kinematic analysis and using several stations. And based on these calculations, we can estimate the magnitude of the earthquake is more than 7 in the, within 60 seconds. So we suggest that we can have we can combine our GPS data together with the seismic data in order to estimate the magnitude, and this will become part of the earthquake warning system and also tsunami warning system. And back to the conclusion. So we need to define the earthquake source, learning from the lesson that we can learn from Palu in South Java subduction area. We need to really understand the seismic sources. Based on our research, that this area divided into 3 different segments. So the main question is whether those 3 segments may broke as one single segment, as it happens in Japan, the Tohoku area, or maybe this segment will be produced in earthquakes with smaller magnitude. That's the question that we need to answer. And the second one, we need to update our seismic hazard map for Java Islands based on the PSHA, or maybe by using the event base. And now we try to one of our doctoral students now trying to estimate the hazard in Java Island using event base and calculate the risk in Java Islands. And finally, together with other expertise, together with Ibu Harkunti, Hamza, and other scientists, we will try our best to do the mitigation in Java Islands. Thank you for your attention.
Okay, thank you very much, Pak Irwan, for the interesting presentation. So I welcome to participant. If you have question, you can raise your hand or type your question in the chat box. So yeah, while we are waiting from question from the participant, I also have question to Pak Irwan. We're talking about the importance to update the PTSA in Indonesia. So could you explain, is there any plan to improve the observation system in Indonesia? I think in Japan now, they are installed a very dense ocean bottom pressure sensor and also a very rapid seismometer. So is there any plan to also develop this kind of system in Indonesia?
Thank you, Ibu Alin, Ibu Karin, for your questions. Yes, having a good observation network is very important for a country like Indonesia. Yeah, and then as you mentioned, having the ocean-based observation, for example, sea floor deformation system, just like what they have in Honshu and in Honshu area in Japan, I think this will be very important. And then also in addition to that, pressure cable system, ocean bottom seismometer. So that will really enhance our understanding on the seismic source in the south of Java. And I think it is a must for a big country like Indonesia, to have such kind of observation systems. And so I clearly agree with your idea, and I hope in the futures the work that has been done by Ibu Harkunti, installations of the cable system in the west coast of Sumatra will be extended to Sunda Strait, or maybe to the south coast of Java. Thank you.
Thank you very much for your answer, Pak Irwan. And while we are waiting, maybe Ibu Harkunti, could you please also answer the question? Maybe, yeah. Sorry. I'm sorry. There are questions from Aditya Guzman. So yes, Pak Aditya, you can ask the question.
Thank you for your presentation. It's really nice to see you have added around like 300 crustal fault into the probabilistic seismic hazard map. I would like to just add that this kind of map really important to build a probabilistic tsunami hazard assessment map. So I'm just wondering, what is your strategy in increasing the number of crustal faults in the future, considering there are so many of them? One point that I've learned that probably to study tsunami hazard, we are interested in faults that may generate earthquake like larger than 7.
Okay, Pak Adit, thank you for your kind comments and also questions. Well, my strategy probably is very personal opinions, but I really hope that we as a country will have a national strategy for updating our national seismic hazard map. But my strategy is, the first one is doing the collaborations, Pak Adit. So it seems to be impossible to divine all the active faults for a country like Indonesia. We are a very big country, so maybe one of my first strategy is doing a collaboration with as many scientists as possible, not only from Indonesia but for other countries. So having a good collaborations is we will already prove that by doing collaborations we may increase our knowledge for in terms of the seismic hazard earthquake sources in Indonesia. And the second one, as already this issue already raised by Ibu Alin, is having a good observation network. And the third one, we really hope that all the institutions, governmental Indonesian, open and share their data. And this is I think it's very important. Luckily, now we have more than 200 continuous GPS data in Indonesia. So really hope those data will be open to publics, and every scientist, not only from Indonesia, but for our country, may analyze the data, and also the seismic data together with other data will be open to public. And I believe that we may produce a good research and publish a good paper, and in return, we will have a better strategy for disaster mitigations. I really hope that I answer your questions.
Thank you.
Thank you, Pak Adit, for your question. So we still have 2 minutes for question and answer. Is there any question from the participant? Okay, I think that's all for the session delivered by our invited speaker. So I would like to say thank you for all the invited speaker, Ibu Nining, Pak Hamzah, Ibu Harkunti, and Pak Irwan for the great presentation and also a fruitful discussion. And now we are moving forward to next session. It is the the presentation from the presenter. So the first presentation will be delivered by Candida Aulia de Silva Nusantara with the title of presentation Mapping of IOC UNESCO Tsunami Ready Indicator in the Pangandaran Village, Indonesia. So Candida, the time is yours.
Thank you, Ibu Karin. I think I've already sent the video presentation.
It is beautiful.
Okay, so just please, please wait a moment.
In this beautiful occasion, let me introduce myself. My name is Candida Aulia de Silva Nusantara. First of all, allow me to present the result of our research we titled Mapping of IOC UNESCO Tsunami Ready Indicators in the Pangandaran Village, Indonesia. This research was carried out with Mr. Wiwin Windu Paranata and Mrs. Intan Hayati Ningsih from Research Group of Hydrography, Faculty of Earth Sciences and Technology, Institute Teknologi Bandung, and with Mrs. Nuraini Rahma Hanifa from Research Center of Geotechnology, Indonesian Institute of Sciences. Let's get into the first part of this presentation. Pangandaran Village is an area with enormous tourism and economic potential. However, as we know that Pangandaran is very vulnerable to a tsunami disaster as happened in 2006 with a magnitude of 7.7. Based on a study from the National Center for Earthquake Studies or PUSGEN, the southern region of Java, especially West Java and Central Java, has a greater potential for earthquake with a magnitude of 8.7. Therefore, Pangandaran Village needs to prepare the mitigation efforts to prepare for the tsunami disaster. IOC UNESCO has formulated 12 tsunami-ready indicators to assess the preparedness of an area against a tsunami disaster. Through this tsunami-ready recognition, communities become aware of the risk they face from the tsunami and take steps to address them. Therefore, in this study, a mapping of tsunami-ready indicator was carried out to determine the readiness of Pangandaran Village to overcome the tsunami disaster. In this study, the research area was determined in a Pangandaran village according to what can be seen in the image on the slide. In the mapping of tsunami-ready indicators, data is needed to fulfill these indicators. The data collection was obtained by conducting interviews and field data collection, which was carried out on 19 to 22 March 2021 from Pangandaran Village Government, BPBD Pangandaran Regency, Pangandaran Village Community Preparedness Forum or FKDM, and the Pangandaran Regency Tourism Office. Besides that, we also conducted a field survey to find out the distribution of evacuation sign and tsunami shelter. The next part of this presentation is results and discussion. The results of the mapping of indicator number 1 have designated and mapped tsunami hazard zone, which can be seen in the slide. Based on the modeling carried out by Windu Pranata et al. 2020, Pangandaran has a potential to be completely inundated due to a tsunami with an earthquake 8.7 magnitude, except in a nature reserve area in the south part of Pangandaran village that have a hilly topography. Based on the result of indicator 2, the Pangandaran village government already has data related to people who have the potential to be affected by the tsunami with a total of 11,247 Pangandaran residents. Of the total, 44 are disabled and require special attention. The specific data can be seen in the slide. In addition, based on the tourism office data, visitors of Pangandaran can reach 110,000 visitors in a day, based on data from January 2018 to March 2020. And then next, move to indicator number 3. Have a public display of tsunami information. Public information, such as a tsunami hazard information board and a tsunami evacuation sign, has already built in Pangandaran village. However, based on the field survey, at least 31 tsunami evacuation signs are wrong in the coordinate or missing when we match with a BPBD Pangandaran Regency data. The next one is indicator number 4. Pangandaran village already have economic resources with a village fund that has already budgeted for specifically for tsunami disaster management. And then the infrastructural resource itself that the Pangandaran village has already placed that designated as evacuation location, namely the nature reserve in the south part area of Pangandaran village, and then tsunami shelter in the boundary of Pangandaran village and Pananjung village, and some hotels with a high-story building in the Pangandaran village itself that can be used or designated as evacuation location. And then the next one is political resources. The Pangandaran village has no specific policy regarding the emergency response condition, such as emergency response plan, because it is still in the form of a flowchart, and the Pangandaran village government and village community preparedness forum of or FKDM still in a way to making the emergency response plan itself. And then move to social resources. The Pangandaran village has already a community preparedness forum or FKDM Pangandaran village, Linmas, fishermen's community and tourism entrepreneurs community as a community that can be empowered related to the tsunami mitigation efforts. Next is indicator number 5. As we can see in the slide, Pangandaran village has at least 4 tsunami evacuation maps, but with these differences in the tsunami evacuation map, it is also indicate the differences in information presented in the evacuation map itself, especially the detail of the information and the destination of a tsunami evacuation. For example, the picture in the lower left that shows that I highlight with this laser is the destination of the tsunami evacuation is going to hotels in the Pangandaran village, but the others is the destination of the tsunami evacuation uh, is going to the shelter, the nature reserve area, and to the Grand Mosque of Pangandaran. A uniform and mutually agreed upon tsunami evacuation should be required so as not to cause a confusion to the visitors or to the residents who are read the evacuation map itself. Then the indicator number 6, development and distribution of outreach and public education materials. The development of education material is in the Goes to School program that held by Pangandaran Regency BPBD or disaster agencies, which provides education to schools in the Pangandaran area in general and Pangandaran village also. In addition, the PMKG also has the tsunami disaster education materials that are made and can be applied in Pangandaran area or other area that can be used for education about the tsunami disaster itself. Next one is indicator number 7 and indicator number 8. These two indicators are fulfilled with these three regular activities that held by Pangandaran village government or by BPBD Pangandaran Regency. These activities are Disaster Preparedness Day that held on the 26th of April, and the commemorating of the Pangandaran Tsunami 2006 on 17th of July, and then a go-to-school program that held by BPBD Pangandaran Regencies. Besides these routine activities, in Pangandaran, there were also educational and preparedness activities eventually, such as IO Wave that takes in 2016, Geophysics Field School or Sekolah Lapang Geofisika in 2020 that held by BMCG and BNPB, and Dextana Expedition in 2019 that held by BNPB. And then the next one is indicator number 9. Have a Tsunami Emergency Operation Plan or EOP for the community. As I mentioned in indicator number 4, the Pangandaran village does not yet have an EOP related to tsunami disaster. It is still in the form of flowchart that can be seen in the slides. So we recommend that the Pangandaran village government or FKDM Pangandaran village have to make the EOP document as fast as it can, so it can fulfill the indicator number 9. Let's move to indicator number 10. When tsunami or earthquake occur in a Pangandaran village disaster preparedness team consists of FKDM and Linmas will coordinate to respond to disaster events and disseminate the information to public. In addition, the Pangandaran village also has a command center and dissemination device that has CCTV to monitor tsunami, sirens, and loudspeaker that can be used to disseminate the information of the tsunami itself. The command center and dissemination device can be seen in the picture in the slide. Then let's move on to the last two indicators, the indicators number 11 and indicators number 12, namely the ability to receive tsunami alerts from the official and disseminate tsunami alerts to the public. As can be seen on the slide, the media used to receive and disseminate alerts are media that depends on the electricity and internet signals. In fact, when a big earthquake occurs, the infrastructure can be damaged, causing damage to electricity and cut internet connection. Therefore, we also recommend using traditional equipment, such as a radio telephone to receive the tsunami alerts, and bamboo clappers or kentongan in Indonesia, or bells to disseminate the information of tsunami alerts to the public. Based on the mapping above, we can conclude that Pangandaran village has complete resource of a tsunami management. Of the 12 indicators, only indicators number 9 is incomplete, where the Pangandaran village only has a flowchart for its emergency operation plan, not in the form of a detailed document. So it can be said that 11 of 12 indicators have been completed by Pangandaran village, or about 92% of all indicators. Although some things can be improved, these are very good to be the beginning of implementing tsunami preparedness in Pangandaran. That's all my presentation. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Your presentation, Candida. So actually, reading your name first, I didn't thought that you are Indonesian because of your name is quite. I thought you are from the South American something. So it's quite interesting. Okay. So is there any question from the participant? Okay. While we are waiting, the question, I have a question for you. I see there are quite a lot of indicator. There are at least 12, I think, indicator. So from your analysis, which one is the weakest and probably the most critical that should be improved in Pangandaran?
Okay. Before I answer the question, I would like to say thank you in advance to the MSAT committee for conducting this seminar. And first of all, I would like to say good morning to the moderator, Ibu Karin, to Ibu Profesor Nining, to Bapak Irwan Melano, Pak Amsal Latif, and Mr. Hakunti as the invited speaker for the inspiring presentation before. Regarding to the question, the weakest indicator that I said before is in the indicator number 9, that because the Pangandaran village doesn't have emergency operation plan or EOP, and it is still in the flow chart. It is really, really important for Pangandaran village to have the emergency operation plan documents so the Pangandaran village government, the Village Preparedness Forum or FKDM or Linmas can coordinate or can can response the tsunami or earthquake and the tsunami disaster regarding with this EOP documents. If this documents is not yet made or not existent, it can make the confuseness in the community itself. I think that's all my answer for the question, Bu Karina.
Oke, thank you for your answer. Mungkin ini ya, Bapak Ibu, jika ada yang ingin bertanya dalam bahasa Indonesia juga dipersilahkan, boleh ditulis di chat box atau raise hand. Oke, kita masih ada waktu 2 menit, jadi kita tunggu apabila ada pertanyaan lagi. Oke, mungkin ada pertanyaan, Bapak Ibu? Okay, I think that's all. Thank you very much for your very interesting presentation, Candida. So now we are moving to our second presentation that will be delivered by Willy Evander Pradipta. This is a research conducted by Marta Alfianingsi with the title Exposure of Building and Population to Tsunami Hazard in Pangandaran Beach, Indonesia. So to Marta and Willy, time is yours.
Okay, I think we have already sent the video.
Okay, so let's wait a moment to make the committee to play the video. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. On this occasion, I will represent my group to present the result of the paper that we have written. Before we start, I will introduce myself. My name is Willy Vander Pradipta, and others Marta Alfianingsih, Intan Hayatiningsih, and Nuraini Rahma Hanifa. The title of the paper is Exposure of Building and Population to Tsunami Hazard in Pangandaran Beach, Indonesia. As for the opening section regarding the background of writing this paper, there are 3 backgrounds. The first is, in 2006, Pangandaran village experienced an earthquake measuring 7.7 magnitude, which was followed by a tsunami. And the second, the National Earthquake Study Center or PUSGEN released a map of the source and hazard of an earthquake measuring 8.7 to 9.2 magnitude in a megathrust on the island of Java. And the last, Pangandaran Village is a tourist area that makes community activities center in coastal area. The purpose of this study was to create a tsunami Indonesian map and see the wide range of impact from the 2 scenarios, see the affected buildings, and see the affected population, which this research can be used as the basis for government policy making and carrying out tsunami disaster mitigation efforts. Then in the data and method section, can be seen in the picture on the right is an area of Pangandaran which is bordered by a blue line, which serves as the village boundary, Pangandaran and Pananjung village. There are 4 data used in this paper. The first, Tsunami Indonesian data for the first and second scenarios. Indonesian data is the result of modeling carried out by Windu Pranata in 2020. The Indonesian tsunami first scenario is the historical Pangandaran 2006 scenario, while the Indonesian tsunami second scenario is a probabilistic scenario, and the second orthophoto data of Pangandaran and Pananjung village, and the third building data obtained from orthophoto digitation result, and the last population data obtained from the Central Statistic Agency in 2021. As for the method used in this paper are, the first is classification of exposure level. Tsunami height are classified into three classes as shown in the table. The second is overlay tsunami Indonesian data with buildings. Overlay of tsunami and building Indonesian data is carried out to see the affected buildings and the affected population. And the last, distribution of tsunami affected population. The distribution of the affected population is obtained from the affected buildings. It is assumed that the population in the village is only found in each building. Then, in the result and discussion section, can be seen in the image on the left, which is a map of the tsunami Indonesian in the first scenario, while the image on the right is a map of tsunami Indonesian in second scenario. The green image shows the height of the tsunami Indonesian below 1 meter, then the yellow one shows the height of the tsunami Indonesian of 1 to 3 meters, then the red one shows the tsunami height above 3 meters. The topography affected in the first scenario class 1 is 98.6, while in second scenario it is 340.5. Then in class 2, first scenario it is 9.9 hectare, while in second scenario it is 52.4. In class 3, first scenario there is no affected topography, while in second scenario it is 474.4. The size of the affected building in first scenario in Pangandaran village is 1,189, while in Pananjung village it is 149. Then in second scenario in Pangandaran village it is 4,216, while in Pananjung village it is 4,039. Distribution of affected population can be seen on the table. Based on the result of the study, it can be seen that the impact in second scenario in Pangandaran village is 4 times greater than in Pananjung village, 27 times greater than first scenario. And the conclusion. Based on the result of data processing, it can be seen that the affected area in first scenario in Pangandaran village is 91.6 hectare or 13.3% of the total of Pangandaran village, and Pananjung village of 16.9 hectare or 4.6% of Pananjung village area. While in the second scenario tsunami Indonesian map, the area affected in Pangandaran village is 687.1 hectare or 73.7% of the total area of Pangandaran village. Meanwhile, the affected area in Pananjung village is 360.5 hectare or 100% the affected area. The building affected in first scenario for Pangandaran village are 1,040 buildings and 149 buildings for Pananjung village. On the map of building affected by second scenario in Pangandaran village, there are 4,216 buildings. In Pananjung village, there are 4,039 buildings, or all buildings in the village are affected by the tsunami. As for the population distribution affected in first scenario for Pangandaran village, as many as 2,765 people and 351 people were affected in Pananjung village. The population affected by second scenario in Pangandaran village amount to 11,029 people, while in Pananjung village there were 9,493 residents, or the entire population in the village was affected by tsunami. And the suggestion. Data on buildings in Pangandaran village and Pananjung village have not been classified based on their use. The building data should be classified into economic facilities, critical facilities, public facilities, and others. This is to see the location of the affected building whose usefulness is essential based on their function. And the second, based on the map of the potential for tsunami Indonesian that has been made and the impact of the affected buildings, a mitigation strategy can be made in the form of an evacuation map in the event of a tsunami. And the map can be used as a basis for socializing and simulating tsunami evacuation for the community in the Pangandaran tourism area. The following are the references we use in writing this paper. Thank you so much for your attention. It is hoped that the suggestion from the audience for this paper can be better. Thank you.
Okay, thank you very much for the presentation. So on behalf of the committee, I would say sorry if the slide is not really clear due to the unstable connection in Indonesia. So if you want to watch a better resolution, you can search on the YouTube and type Oceanography ITB, or you can see on the chat box and click on the link sent by the committee. Okay, now we are going to the question. Is there any question from the participant? So Bapak Ibu silahkan jika ada pertanyaan dalam bahasa Indonesia juga tidak apa. Okay, while we are waiting, actually I have a question. So it is interesting from the result of your model, especially scenario 2, that the two location dedicated as evacuation place, which is one of them is tsunami evacuation shelter, it is not safe, yeah. It is like inundated by the tsunami. So could you explain about this result? Is the tsunami shelter not safe in this scenario? Thank you.
Okay, thank you for the question. So because in second scenario is the scenario with the greatest magnitude power, this scenario 2 earthquake segment is located in West Java and Central Java, which is near Pangandaran village, as well as the classification of tsunami Indonesian Hague. It is classified into three classes: the Hague of the tsunami Indonesian that occur was in the range of 0 to 23 meters. So that most of the Pangandaran area was classified as class 3 with a tsunami Indonesian Hague of more than 3 meters. So the shelter building in Pangandaran village is not safe for scenario 2. Maybe in this paper, I and and Marta not see the building, not see the type of the building and height of the building, just see the affected building. So maybe in for the next research, the building can be classified and can be see by the height of the building, the type of the building. Thank you.
Yes, thank you for your answer. So yeah, that is maybe also one of the interesting factor, especially if you talk about shelter. So probably the participant and also the reader will be very curious why the shelter, is it safe or not? Okay, so I think, is there any question? We have 1 minute. Okay, I think no other questions. So thank you very much for Marta and Billy for very interesting presentation. Now we are going to the last presentation. So the last presentation will be delivered by Devita Vega Koswara with the title Characteristic of Potential Tsunami Evacuee and Evacuation Infrastructure in Pangandaran Beach, Indonesia. So for Devita, time is yours.
Okay, thank you, Lain. Hello everyone, my name is Devita Vega Koswara. I would like to present our research about characteristics of potential tsunami evacuee and evacuation infrastructure in Pangandaran Beach, Indonesia. The background of this research are Pangandaran Regency is a strategic area that supports various economic and social activity. The existence of this strategic area is threatened by the potential of tsunami disaster, especially from the megathrust along the south coast of Java Island. One of the efforts to ascend tsunami preparedness is to conduct evacuation plan and drill. Based on proposed tsunami occurrence, it is known that success of evacuation during disaster is still limited by lack of community knowledge, preparedness, and limited infrastructure. So, the purpose of this study is to identify people behavior in carrying out evacuation and actual condition of the current evacuation infrastructure, which is later used to obtain comprehensive information as the basis for evacuation plan preparation. The methodology used in this research are first, distributing questionnaire survey. The questionnaire survey was carried out in October 2020 and March 2021. The survey was conducted face-to-face with residents, but the questionnaire distributed were based on online forms, in this case using Google Forms. On October 2020, the question was prepared to identify the source of information on potential tsunami disasters, as well as the knowledge of the community on tsunami evacuation. And then, in the second survey on March 2021, the question was prepared to explore information related to the behavior of community evacuation in tsunami occurrence. The interview was also conducted in research. The interview conducted with the government of Pananjung Village and Pangandaran Village, the member of the disaster response community, and the resident. Through the interview, more in-depth information could be obtained. And then identification and retrieval of information related to temporary evacuation site and location of evacuation site. Identification and geotagging activity were carried out simultaneously to determine and validate the location and condition of the evacuation supporting infrastructure, which the temporary evacuation sites and evacuation site. Last, calculating the capacity of the alternative temporary evacuation site. Budiarjo on 2006 explained the assumption and formula to calculate the capacity for evacuation of some building functions which are potentially suitable for vertical evacuation, as example for hotel. If 10% of the hotel rooms in the hotel can be used, the capacity for evacuations are 26.3% of building area, and if 100% of the hotel room can be used, the capacity for evacuation are 93.8% of building area. So the result of the study are first, from distributing questionnaire survey and interview in our part knowledge of tsunami disaster. Based on respondent result, it is known most of residents have never participated in disaster preparedness training and conducted a simulation evacuation. Then about public awareness to conduct disaster evacuation. From the questionnaire result, it is known there are still residents who will only evacuate if they see the waves coming, which is quite dangerous if they do not have time enough to reach the evacuation site. And then about evacuation preparation time. After the resident build the earthquake or receive the tsunami warning, they choose to evacuate. But some of residents also need time to prepare for evacuation. The evacuation preparation time is used by residents to prepare evacuation needs such as vehicle used to evacuate, carry out valuable at home, or ensure the evacuation of other family members. The preparation time before evacuation can be seen on the figure that some president need time maximum 13 minutes. And then about knowledge of evacuation destination and routes. Based on the result, is also known that for residents who do not know the purpose of evacuation also do not know the evacuation route. Furthermore, the result of the questionnaire show that while 13 residents do not know the path to evacuation site, the evacuation destination can be seen in Table 1. And last, about evacuation method and estimated travel time for evacuation. We also know most of residents choose not to use the mode of transportation because they consider that the use of vehicle will delay the evacuation due to congestion. The estimated travel time to the evacuation site is varies depending on the destination and mode of transportation chosen. And the second result is about evacuation infrastructure condition in Pangandaran. On Table 2 and Table 3, we can see the capacity of main TES and the alternative TES. Based on the result of the tsunami modeling with an earthquake scenario of 8.7, it is known that the total population affected in Pangandaran's tourism area, namely Pangandaran Village and Pananjung Village, is 100%. The total population in both villages is 20,702. In addition, Pangandaran area is a tourist destination that is regularly visited by tourists. Based on data from Pangandaran Tourism Office, it is known that in one day the number of tourists visiting can reach 100,000 people. So, the three Pangandaran main TES can accommodate approximately 11,900 people, while the capacity of alternative TES, if utilized 100%, can accommodate 21,291 people. This indicates that the official TES and the new alternative TES can accommodate the villagers and just some of tourists if the number of tourists reach the maximum. And last, about evacuation site. According to data, the number of evacuation sites in Pangandaran and Pananjung Village among 109 sites. However, based on the survey, the number of signs found was only 78, consisting of 45 appropriate signs between the PPPD data and survey conducted and 23 unmapped signs, which can be prevented by have coordinate errors. Meanwhile, the other 31 signs were not found in the field. This can be caused by missing signs or coordinates on the data do not match in the field. From the result of the survey, we also know that there are still signs with the damaged condition, such as bedding can be seen and show misleading direction. So the conclusion of the study is based on the respondent result. It is known most of the residents have never participated in disaster preparedness training and conducted simulation evacuation. This can lead to limited knowledge of citizens related to disaster and disaster evacuation, as well as lack of lack of preparedness for tsunami disaster. The lack of community preparedness for disaster is also reflected in the decision to evacuate, where there are still respondents who will evacuate if they see the waves coming. It is quite dangerous if the residents do not have enough time to reach the evacuation site or a safe place. In addition, to carry out evacuation, there are residents who need time to prepare. Residents will suffer if they go directly to place that is far from the beach. Most of the residents choose not to use the modern transportation because they consider that the use of vehicle will delay evacuation. And then the Pangandaran MTS accommodated approximately 11,000 people, while the capacity of alternative TES, if utilized 100, can accommodate 21,000 people. This indicates that the official TES and the new alternative TES can accommodate the villagers and some of the tourists. From the result of the survey, it is also known that there are signs with the damage conditions such as lighting cannot be seen and so misleading the lesson. And then suggestion the addition of the number responded is done to get more accurate results. The capacity of the evacuation site needs to be studied further, and field validation activity are needed to verify the data result. The existing building can be utilized as temporary evacuation site. That's all for me. Thank you. And sorry if there are still a lot of mistakes. Once again, thank you.
Okay, thank you very much for your presentation, Ms. Devita. So, is there any question from the participant? You can raise your hand or type in the chat box. Bapak Ibu juga silahkan jika ingin menggunakan bahasa Indonesia.
Evacuation training is also conducted by conducted. are also implemented in school as an effort to create disaster response school. So I thought the Pangandaran village also conducted the simulation or training. Maybe the can be more improved dari sebelumnya. Sorry for the error of my English.
Actually, there is no problem. So if you want to explain your answer in Bahasa, it's also okay. So if you want to answer in Bahasa, it's okay, please.
Oke, thank you Ibu Karin. Jadi sebenarnya sekarang di Pangandaran baik BPBD maupun pemerintah dari Pangandaran, Desa Pangandaran maupun Pananjung sedang mengupayakan training maupun mengadakan simulasi dengan lebih periodik atau lebih banyak mengupayakan training tersebut. Harapannya ke depannya partisipasi dari warga Pangandaran maupun Pananjung akan lebih meningkat dari sebelumnya.
So because time is limited, thank you very much for all the participants. So the breakout room will be closed in at least 30 seconds. So thank you very much for your participation. I think to close this session, I would like to, with the heartfelt, wish that this conference will be an important step for the collaboration and participation with many scientists from international cooperation to tackling marine hazard challenge. So thank you to all speaker, presenter, and participant. Please be safe and healthy. May God always protect us all. Thank you very much and see you.
Recording in progress. Di sini konsultan cuaca itu pekerjaannya seperti memberikan analisis cuaca tentang bagaimana suatu keadaan itu harusnya dilakukan. Umumnya mereka bekerja di perusahaan seperti pertambangan, perminyakan, dan pertanian. Ada juga lulusan-lulusan dari kami itu yang menjadi kepala departemen di BPPT dan kepala departemen di BMH.
Saya akan menjelaskan tentang prospek lulusan oceanografi. Untuk lulusan para oceanografi biasanya terkonsentrasi menjadi 3 bidang, yaitu adalah seorang peneliti, menjadi seorang surveyor di lapangan, atau bahkan menjadi seorang analis di suatu perusahaan-perusahaan. Dan di sini untuk peneliti sendiri biasanya untuk mahasiswa yang ingin melanjutkan studi di berbagai universitas dalam atau di luar negeri, seperti Tokyo Institute of Technology, di Hamburg University, atau bahkan bisa sampai Massachusetts Institute of Technology. Dan untuk field surveyor, itu bagi orang-orang yang suka kerja di lapangan, tapi khususnya di laut. Contohnya di perusahaan seperti Schlumberger, di perusahaan Fugro, atau perusahaan seperti Pagio. Dan yang ketiga adalah sebagai seorang analis lingkungan. Biasanya dibutuhkan untuk memberikan informasi kepada perusahaan-perusahaan yang melakukan industri migas atau pertambangan. Di sini seperti Freeport, Newmont, atau juga bahkan perusahaan minyak seperti Pertamina, Total, atau bahkan British Petroleum.
Geodis itu sebenarnya bisa bekerja di mana-mana nih ya. Jadi untuk melakukan sebuah kegiatan kita butuh perencanaan. Geodis itu bisa mulai dari sebelum perencanaan untuk merencanakan pemantauan sampai evaluasi gitu kira-kira. Jadi kita bisa bekerja di manapun, BUMN, minyak, apalagi perusahaan yang butuh survei atau peta offshore. ya pegawai negeri juga bisa lah, BPN atau BIG gitu.
Prospek kerjanya itu biasanya lulusan geologi ini masuknya ke industri, apakah itu industri berminyak,
Halo, apa dia jadi?
ataupun industri panas bumi. Jadi tidak sedikit juga lulusannya menjadi dosen, ataupun konsultan, ataupun orang-orang yang bisa keluar dari
Established in 1920 with the name Technische Hogeschool te Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia.
Ladies and gentlemen, we kindly remind you that we will have two keynote speakers this afternoon. Dr. Wenju Chai, the Director of Center for Southern Hemisphere Oceans Research, Australia, and Dr. Yasumasa Miyazawa, the Deputy Director of Application Laboratory, JAMSTEC, Japan. For all participants, we kindly remind you that the list of attendance can be accessed through the link provided on the chat room. We will also hold another parallel session afterward, and each session has different topics as shown later on your screen. And participants are allowed to join the room to your liking. For more information, please check our website at msat.fitb.itb.ac.id. In the meantime, we will have lunch break for 90 minutes. See you at 1 p.m. Indonesian Western Time.
is our future. We understand, cooperate, and advance for a better future of the ocean. Korea-Indonesia Marine Technology Cooperation Research Center. And Fisheries of Korea and the Coordinating Ministry for Maritime and Affairs of Indonesia. In May 2018, the implementation arrangement was signed. In September, the MTCRC was opened at the Itebe Cirebon for the construction of the boat Ara, supporting the accident of Sriwijaya Air Flight, and planning for the installation of a marine chemical analysis lab. The MTCRC is jointly operated by the KIOST, the leading marine science and technology research institute in Korea, and the Itebe, the top science and technology university of Indonesia. There is a joint committee composed of 10 governmental representatives of both sides as a key decision-making body. Also, under the leadership of co-directors, the Planning and Administration Department, Research and Technology Department, and Education and Training Department are in operation. For effective cooperation with related institutions in Indonesia, we also operate the Jakarta office inside the Coordinating Ministry for Maritime and Investment Affairs. The MTCRC conducts 3 main activities and 2 support activities. First, to build the cooperation platform, the MTCRC holds joint committees and promotes research cooperation with related institutions, including government departments, institutions, and universities on marine science and technology of Indonesia. Second, the MTCRC continuously discovers and conducts joint research projects on current ocean issues, such as operational oceanography forecasting systems, ocean satellites, ocean energy, and ocean waste management. Third, the MTCRC operates programs to foster marine science and technology experts, including Itebe and KIOST Special Masters programs, and invitational masters and doctoral programs in Korea. Fourth, the MTCRC supports various local communities. And lastly, oversees the effective use and operation of research and research equipment while conducting the ODA project launched in 2019 for enhancing the capacity of marine science and technology. The MTCRC is leading the development of marine science and technology in Korea and Indonesia as an intergovernmental joint research center. The 2 countries will continue to build a prosperous future based on various cooperation projects and training of talents and workforce.
Saya Ron Milano, Dekan Fakultas Ilmu dan Teknologi Kebumian Institut Teknologi Bandung. Selamat datang pada putra-putri terbaik di Fakultas Ilmu dan Teknologi Kebumian.
Dari namanya saja itu adalah ilmu dan teknologi kebumian, maka di fakultas ini diajarkan semua yang berkaitan dengan kebumian, terutama yang ada di Indonesia ini, mulai dari hasil buminya yang cukup kaya kita dengan minyak dan gas bumi, kemudian ada bencana geologi juga dipelajari di sini, dan juga rupa bumi yang dipelajari di geodesi dan geomatika, dan juga Indonesia adalah negara keempat yang memiliki pesisir terpanjang di dunia, dan itu diajarkan di oceanografi, dan juga ilmu tentang iklim yang dipelajari di meteorologi. Jadi silakan kalau adik-adik dari SMA akan masuk ke FITB, maka yang siap untuk mempelajari teknik tentang kebumian, silakan, selamat datang di FITB.
prospek kerja sendiri, kebanyakan lulusan kami itu ada yang menjadi peneliti, di mana dia melanjutkan studi S2, S3-nya itu seperti di Jepang, Jerman, dan Prancis. Kemudian kebanyakan juga menjadi konsultan. Di sini konsultan cuaca itu pekerjaannya seperti memberikan analisis cuaca tentang bagaimana suatu keadaan itu harusnya dilakukan. Umumnya mereka bekerja di perusahaan seperti pertambangan, perminyakan, dan pertanian. Ada juga lulusan-lulusan dari kami itu yang menjadi kepala departemen di BPPT dan kepala departemen di BMK.
Sekarang saya akan menjelaskan tentang prospek lulusan oceanografi. Untuk lulusan para oceanografi biasanya terkonsentrasi menjadi 3 bidang, yaitu adalah seorang peneliti, menjadi seorang surveyor di lapangan, atau bahkan menjadi seorang analis di suatu perusahaan-perusahaan. Dan di sini untuk peneliti sendiri biasanya untuk mahasiswa yang ingin melanjutkan studi di berbagai universitas dalam atau di luar negeri, seperti Tokyo Institute of Technology, di Hamburg University, atau bahkan bisa sampai Massachusetts Institute of Technology. Dan untuk field surveyor, itu bagi orang-orang yang suka kerja di lapangan, tapi khususnya di laut. Contohnya di perusahaan seperti Schlumberger, di perusahaan Fugro, atau perusahaan seperti Pagio. Dan yang ketiga adalah sebagai seorang analis lingkungan. Biasanya dibutuhkan untuk memberikan informasi kepada perusahaan-perusahaan yang melakukan industri migas atau pertambangan. Di sini seperti Freeport, Newmont, atau juga bahkan perusahaan minyak seperti Pertamina, Total, atau bahkan British Petroleum.
Jadi di situ sekarang bisa bekerja di mana-mana nih ya. Jadi untuk melakukan sebuah kegiatan kita butuh perencanaan. Jadi di situ bisa mulai dari sebelum perencanaan untuk merencanakan, pemantauan sampai evaluasi gitu kira-kira. Jadi kita bisa bekerja di manapun, BUMN, minyak, apalagi perusahaan yang butuh survei atau peta offshore, ya pegawai negeri juga bisa lah, BPN atau BIG gitu.
Prospek kerjanya itu biasanya lulusan-lulusan geologi ini masuknya ke industri, apakah itu industri perminyakan, industri pertambangan, ataupun industri panas bumi. Jadi tidak sedikit juga lulusannya menjadi dosen, ataupun konsultan, ataupun orang-orang yang bisa keluar.
Established in 1920 with the name Technische Hogeschool Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's one-century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesa Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than campus site located in Ganesa, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been internationally accredited from accreditation boards around the world, namely from the United States of America, ASEAN, Germany, Japan, the United Kingdom, South Korea, and the number of accredited programs is expected to increase in the near future. ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors. For instance, Insinyur Soekarno as the first President of the Republic of Indonesia, B.J. Habibie as the third President, Iskandar Ali Shahbana as the father of the communication system in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization. In our over 100-year journey, ITB has a long-standing as the leader in advancing science, technology, art, and social and humanities as well. ITB is striving to play a significant role in solving Indonesia's challenges while improving its capacity to compete globally. The alumni are our pride, who continue to share our values and significant contribution to the nation's development. To continue our tradition, we will always preserve a campus with academic atmosphere that is open to new ideas and experiences, critical and visionary thoughts, accompanied by attitudes that uphold academic freedom in scientific and cultural diversity. We are keen on continuously improving the quality of education, research, and community services, progressing in harmony, in harmonia progressio.
Kalian tahu nggak kalau Indonesia punya akuarium terbesar di dunia? Namanya Piamari Aquarium yang terletak di Pangandaran, Jawa Barat. Piamari merupakan kepanjangan dari Pangandaran Integrated Aquarium and Marine Research Institute yang dibangun oleh Badan Riset dan Sumber Daya Manusia atau BRSD MKP, Kementerian Kelautan dan Perikanan. Akuarium ini digunakan sebagai sarana wisata edukasi dan juga untuk keperluan riset kelautan dan perikanan di Indonesia.
Piamari digagas sejak tahun 2017, di mana di Piamari ini memiliki 3 fasilitas utama. Yang pertama adalah kami memiliki bangunan dormitori yang diperuntukkan bagi para pengunjung, para peneliti, para penjalin kerjasama baik itu nasional maupun internasional. Kemudian kami memiliki juga fasilitas gedung riset. Gedung riset ini tentunya menjadi fasilitas utama dalam melakukan kajian-kajian riset. Kemudian gedung paling utama adalah akuarium, di mana di dalam gedung akuarium kami memiliki 4 fasilitas akuarium besar. Pertama adalah akuarium schooling. Yang kedua, akuarium sentuh atau touch pool. Dan yang ketiga adalah akuarium tunnel, sedangkan terakhir adalah main akuarium. Tujuan dibangunnya Piamari ini adalah untuk mendukung kajian-kajian riset yang dilakukan oleh Kementerian Kelautan dan Perikanan untuk menjawab fenomena-fenomena yang terjadi di Samudra Hindia, sekaligus memberikan edukasi yang disajikan dalam bentuk akuarium yang ada di bangunan Piamari saat ini.
Pembangunan akuarium raksasa ini adalah sebuah pencapaian besar dan berharap dapat membawa manfaat besar bagi dunia riset kelautan di Indonesia.
Jadi ini adalah main aquarium yang merupakan akuarium air laut. Ini memiliki dimensi panjang 32, lebar 10, dengan kedalaman sekitar 4 meter. Nah, di sini ini rencananya kita akan memberi ikan-ikan yang berukuran besar, baik itu ikan pari, ikan hiu, maupun ikan-ikan pelagis yang lainnya. Nah, diharapkan dari ikan-ikan itu kita dapat melakukan penelitian tentang perilaku-perilaku ikan. Bagaimana perilaku ikan dikaitkan dengan kondisi kualitas airnya dan kondisi lingkungan yang ada di sini. Selain untuk kebutuhan eduwisata, yaitu untuk bisa melihat bagaimana keanekaragaman hayati ikan di Samudra Hindia, terutama di Pangandaran, di akuarium ini. Ini adalah tunnel akuarium yang akan kami sulap menjadi nature aquarium, di mana di sini akan kita buat aquascape untuk membuat akuarium ini seperti kondisi di alam. Nah, jika ini sudah menjadi aquascape, ini akan menjadi nature aquarium yang terpanjang di dunia karena memiliki panjang sekitar 47 meter, melebihi akuarium di Portugal yang memiliki panjang 40 meter. Ini adalah kolam sentuh atau touch pool dengan topik tidal pool, di mana di kolam sentuh ini kita akan memasukkan ikan-ikan karang dan juga penyu, ikan pari yang bisa dilihat secara langsung dan juga disentuh oleh para pengunjung. Ini adalah schooling aquarium yang nanti dikhususkan untuk ikan-ikan yang dia berschooling atau berenang dalam kelompok, dalam satu arah yang sama. Ini juga adalah akuarium air laut.
Nah, semoga keberadaan Piamari ini bisa mendongkrak arus wisatawan, serta peningkatan kesejahteraan masyarakat pesisir, khususnya daerah Pangandaran, Jawa Barat, dan Indonesia umumnya. Mari bersama-sama kita ramaikan Piamari Pangandaran, karena di sini kita bisa berwisata, sekaligus belajar untuk mengenal lebih banyak potensi kelautan Indonesia.
An Indonesian passenger plane carrying more than 60 people has gone missing shortly after takeoff from.
The tragedy that left deep sorrow for the Indonesian people came at 2:30 p.m. local time on Friday, January the 9th, 2021. Sriwijaya Air SJ-182 plane with the Jakarta-Pontianak flight route crashed 4 minutes after takeoff from Soekarno-Hatta International Airport. The plane, carrying 62 passengers, experienced a drop in altitude of 10,000 feet in 1 minute, which then lost contact and was declared crashed around the waters of the Thousand Islands. The plane's crash was confirmed by the Minister of Transportation on January the 9th, 2020, when the plane's wreckage was reported by the head of the National Search and Rescue Agency around the location, which is a depth of about 15 to 16 meters. The President of the Republic of Indonesia, Joko Widodo, immediately ordered all authorized agencies to carry out search and rescue operations. As a result, the Indonesian government, along with many organizations, moved to carry out humanitarian missions to find missing victims and carry out investigations related to the incident. The day after the accident occurred, MTCRC, together with the Coordinating Ministry for Maritime Investment Affairs, held a joint integration meeting with related agencies, namely from the Sriwijaya Air Aviation, National Transportation Safety Committee, National Search and Rescue Agency, the Ministry of Transportation Indonesian Navy and other related agencies. MTCRC was assigned by the Coordinating Ministry for Maritime Investment Affairs to participate and assist Indonesia National Search and Rescue Agency in conducting searches on the site where the accident occurred, as well as a part of SJ-182 Search and Rescue Task Force team. Suspected searching areas were divided into 4 zones. Each zone was then surveyed by the ship of Rigel 933 from the Indonesian Navy, Barunajaya research vessel from the Agency for the Assessment and Application of Technology, and research vessel from the Mahakaya Geo Survey team. Also, the ARA research vessel, which was equipped with a multi-beam metrosounder and side-scan sonar, was sent by MTCRC to help the search and rescue operation. Multi-beam metrosounder is a tool used to measure the depth of water, or another term is bathymetry. The multi-beam metrosounder used by MTCRC in this search is a wide swath bathymetry system that produces data with accuracy up to 200 meters depth, which is suitable for shallow water. By using a side-mounted multi-beam metrosounder, the digital terrain map of the sea can be seen and be used to find anomalies on the seabed, such as debris or wreckage from the aircraft. While side-scan sonar is a tool used to provide a view or overview of the seabed. After a depth anomaly is detected using the multi-beam, side-scan sonar can be used to produce a high-accuracy visualization of the seabed, which helps the team to better depict the wreckage of the aircraft. The survey results obtained from the task force will be integrated and submitted to the National Search and Rescue Agency, and later be used to coordinate the diver team as a reference for the dive point. After 4 days of underwater searching, the black boxes were found, and the National Transportation Safety Committee can fully investigate this accident further. This shows how important the role of hydrographic survey in search and rescue operation in the sea. Being among the team of SJ-182 Search and Rescue Task Force, MTCRC actively collaborates with various agencies, with the same goal to conduct the search and evacuation process successfully. Even though bad weather several times happened, it does not make the spirit of the whole team subside in carrying out this mission. Being part of this mission is a valuable experience to MTCRC and contributes more to carrying out surveys at the Indonesia Sea. Unexpectedly, after contributing to this mission, MTCRC received a lot of appreciation from many parties, local and international. Hopefully, in the future, MTCRC can become a marine research center that will have great personnel, advanced survey equipment, and a lot of relationships and support from various stakeholders in carrying out other activities.
What is the distribution of Indonesia's natural resources? Where are the locations of Indonesia's nature tourism potentials? When do the tides change across Indonesia? Where are the locations of Indonesia's hotspots and ring of fire? Where are the locations for development that are deemed safe from natural disasters and can be used to develop a disaster mitigation system? When the public requires answers, decision makers looking for the geospatially based big picture as a base for all geospatial information layers. We are here. BIG has transformed substantially from 1938 to 2011. Their roles and responsibilities in the field of geospatial in Indonesia have grown so that they can stay relevant with the current day and age. Ultimately, in 2011, our agency was born, along with the enactment of the Spatial Information Law. The Geospatial Information Agency is directly under the President of the Republic of Indonesia, in partnership with the Ministry of National Planning and Development. BIG holds the roles of regulator, implementer, coordinator. We prepare the data and regulation while also implementing them at the same time. As a regulator, BIG is responsible to prepare development policies for geospatial information. As an implementer, BIG has a duty to provide a complete spatial information, a digital system to collect various geospatial information that is accurate and integrated with the national and global coordinate systems. We own geodatic information, or the mapping of the Earth's surface, regional physical objects data, position determinant data, seismic activities data, tidal observation data, meteorology and ionosphere layer data. All is available to use as a starting point to develop Indonesia, which encompass natural resources, infrastructure, disaster mitigation, economy, research, tourism, state defense, and security. In doing their role to compile strategic mapping, BIG always works hand in hand with the associated government bodies. We are partnered with as many as 19 ministries and 34 regional governments. Our duty is to prepare spatial policies that refer to the One Map policy. Guaranteed access to information. Credible information. Proper. That is the quality of information from BIG. That is how we participate in the governing of and in the geospatial literacy of Indonesia's society.
The ocean is our future. We understand, cooperate, and advance for a better future of the ocean. Korea-Indonesia Marine Technology Cooperation Research Center. In May 2016, an MOU was signed between the Ministry of Oceans and Fisheries of Korea and the Coordinating Ministry for Maritime and Affairs of Indonesia. In May 2018, the implementation arrangement was signed. In September, the MTCRC was opened at the Itebe Cirebon campus. Afterward, we are continuing various activities for the construction of the boat Ara, supporting the accident of Sriwijaya Air Flight, and planning for the installation of a marine chemical analysis lab. The MTCRC is jointly operated by the KIOST, the leading marine science and technology research institute in Korea, and the Itebe, the top science and technology university of Indonesia. There is a joint committee composed of 10 governmental representatives of both sides as a key decision-making body. Also, under the leadership of co-directors, the Planning and Administration Department, Research and Technology. For effective cooperation with related institutions in Indonesia, we also operate the Jakarta office inside the coordinating ministry.
BUMN minyak, apalagi perusahaan yang butuh survei atau peta offshore, ya pegawai negeri juga salah BPN atau BIG gitu.
Prospek kerjanya itu biasanya lulusan-lulusan geologi ini masuknya ke industri, apakah itu industri perminyakan, industri pertambangan, ataupun industri panas bumi. Tapi tidak sedikit juga lulusannya menjadi dosen, ataupun konsultan, ataupun orang-orang yang bisa keluar.
Established in 1920 with the name Teknische Hogeschool te Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's one-century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesa Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than the campus site located in Ganesa, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been internationally accredited from accreditation boards around the world, namely from the United States of America, ASEAN, Germany, Japan, the United Kingdom, South Korea, and the...
Ladies and gentlemen, good afternoon. Welcome back to our conference. May we have your attention, please? For the next parallel oral presentation, we highly recommend you to rename your Zoom account to make it easier for the committee to help you putting you in the room that you are liking. So, for example, retype as room ABC, room A underscore your name, room B underscore your name. We also would like to remind you that the list of attendance can be accessed on the chat room. So the conference will start in a moment. Honorable ladies and gentlemen, now we will continue with the second plenary session with 2 keynote speeches. The first speech is from Dr. Yasumasa Miyazawa, the Deputy Director of Application Laboratory, JAMSTEC, Japan. And the second one is from the Director of Center for Southern Hemisphere Ocean Research, Australia, Dr. Wenju Chai. These speeches will be moderated by Dr. Eng Aditya Rahmat Kartadikarya SSI MN.
Yes, thank you, Ibu Osi. How are you, Bu?
I'm great, fine. It was
Nice to see
wonderful.
you. Okay, from now on, I will moderate the session. Thank you so much for giving me a time to moderate. So, I will start this keynote session. I found that we just have Dr. Wenju Chai with us today and also Dr. Miyazawa with us. So yes, thank you, Bu. I will I will have this session with me. Okay. Thank you, ladies and gentlemen. It is our pleasure and also indeed my personal pleasure to have two amazing scientists in this MSAT conference. Thank you so much, Dr. Wenju Chai, and thank you so much, Dr. Miyazawa.
Thank you.
And thank you for all participants. In this keynote, we will listen presentation from Dr. Wenju Chai from CSIRO and Dr. Miyazawa from Jamstack. We will have a presentation from Dr. Wenju Chai and then followed by a presentation from Dr. Miyazawa. After two keynote speech finish, we will continue with discussion session, Q&A. And participants in Zoom and YouTube may post their question in the chat box. And we suggest for participants in YouTube, you can move to Zoom. We still have allocation of participants. So if you can move to Zoom, it's easy to interact with speakers later on during the discussion session. And for participants, we are strongly wish to have an active participation by raising a polite words and also nice question. So let's hope the scientific keynote has a fruitful discussion. And before we begin with the first keynote speech from Dr. Wenju Chai, I will read some of his milestones. So Dr. Wenju Chai is a chief scientist at CSIRO and also the director of Southern Hemisphere Ocean Research that specializes in research into global climate variability and also climate change. And he got his PhD in 1993 from Flinders University, Australia. And looking to sound issue. Okay, I think you still.
Can you hear me now?
Okay, yes, we can hear you. Thank you so much.
Can you see my
Please
screen?
continue. Yes, we can also see your screen.
Oh, fantastic. Okay, thank you all. Thank you for having me. I'm sorry I came a bit late. August Santosa just reminded me that the time is on for me. And thank you for the generous introduction. It is a great honor to be able to speak, to be invited to speak in this occasion. And today, I'm going to talk about the IOD and ENSO. ENSO is missing, but the impact under greenhouse warming. This is a series of work in collaboration with many colleagues and supported by many funders. So I'd like to thank them for their support and collaboration. Can I go forward? Somehow I can't go forward. Okay, the problem here. Let me see if I can try to go forward with the screen. I can't move forward my screen, but just give me a sec. I will sort it out. Let me restart again. Come on, why I can't go forward? Sorry. I had to quit the talk and then start again because I can't move forward for some reason. Yeah, but let me start again. Yeah, now I can. So if we start from Australia, Australia's climate actually influenced by three modes of variability. One of them is the southern El Nino mode. So when the high latitude, when the mid latitude pressure is low, southern Australia is high. Southern Australia tend to have lower rainfall. Southeastern Australia, Melbourne, where I am in. And of course, we are also influenced by the Indian Ocean dipole. So when the eastern Indian Ocean is cooler than normal, the rainfall here reduces, and here's where it influenced the Indonesian country's rainfall. The Indonesia's rainfall will reduce, but the teleconnection extends to southeastern Australia. So a partial Indian Ocean dipole in southern hemispheres, winter or spring, normally lead to huge bushfire season in the summer of December, January, and February. And in the Pacific, El Nino tend to also cause a dry condition. These two drivers are common to Indonesia's climate variability as well. So El Nino, Indonesia tend to have dry condition. Partial Indian Ocean dipole, Indonesian tend to have a drier condition, and often we have huge wildfire in Indonesia, as in 1997. And so that is, we often call it as the three-headed dog of Australian climate. So in 2019, the partial Indian Ocean dipole index is very high, and that led to the huge Black Summer fire season in 2019, 2000. And you heard in the news that Sydney, Melbourne had very serious bushfire in that year. In the meantime, in India, we have heavy rainfall. In Southeast Asia, we have heavy rainfall in 2019, and that is because we had that huge partial Indian Ocean dipole. So rainfall actually moved across to the East African country, also to India. If we look at the East African country, there were huge flood and a lot of landslides. And here are some of the statistics. So there are more than 300 people died and more than 2.5 million people affected. So in Australia, we had more than 18 million hectares of area burned. A lot of people lost their life and many more affected through mental health and also air pollution in this bushfire. Now it is called Black Summer. And that is, on top of a very dry season. So this is cumulated rainfall deficit in eastern and southeastern Australia, and cumulative rainfall. Some of them the rainfall are lowest record, temperature are highest on record, and that really contributes to the huge fire in 2019, 2020. So many are suspecting that climate change had played a part in that season. So if we look back in the climate in the past 500 million years of history, climate has been varying, right? So here is very long in the past, and here is more recent. So we are actually in a relatively warm period of the cold period in the geological time scales. And during the past, say 50 million years, Cretaceous period, these are the time series of, you can use it as to represent temperature. And so you had temperature actually gradually cooling down with fluctuation, of course. And about 35 million years ago, we start to have Antarctic glaciation. and then we have the reverse, and then regression again. So, and you can see this climate fluctuation has been actually increasing once we get to a sort of cooler period. We had the rapid glaciation cycles. So this is the sort of late Cretaceous period, 65 million years of the climate change. I'm going to focus on this period, the past 5.5 million years, and you can see the evolution of actually amazing. We are, as we get cooler and cooler, we are getting these bigger cycles. There is the 41,000 year cycle, 100,000 year cycle, and of course there's about 20,000 cycles. So if you look at the past 400,000 years, we are seeing these cycles. We are zooming in, and this is the temperature. So about 4 cycles, the 100-year cycle at work, and then of course there's the dust. Dust, basically when we have a very low temperature, dust peaks, and here is the CO2. So the point here is that in the 100-year cycle, the carbon dioxide fluctuations would take us from a low of 180 ppm to about 280 ppm. So that's the natural geological time scale, the fluctuation of carbon dioxide. And these cycles are driven by what we call Melansky cycles. So basically we have the eccentricity cycle, obliquity cycle, and with every 4 eccentricity cycle, you've got some big cycles and smalls, and so that give us all this climate cycle fluctuation that we are seeing. Yeah. So that's basically the fluctuation of Earth's climate without human intervention that we are expecting to see. So the point is that in 100,000 years, CO2 in the atmosphere would fluctuate by about 100 ppm, 100 ppm. Now, through international effort, we now have a pretty reliable carbon dioxide record over the period 100,000 years cycle, and you can see that in the past 100 years or so, 150 years or so, the carbon dioxide has been really rising sharply, taking us to that natural variability range from 180 to 280. And so without this human-induced carbon emission, we would have been in a process of going through a sort of cold period. We should have started by then, yeah. So this carbon, as you can see, is really very high, and it took us back to 2.5 million years of label. Remember, in about 100 million years ago, the carbon would be about 2,000 ppm. About 2,000 ppm. This is at about 45 million years ago. It's about 1,500 ppm, and at 400, this level, it took us back to the level of 2.5 million years ago. So we are in effect changing the atmosphere very dramatically in terms of carbon concentration in the atmosphere. And so we should be entering into an ice age. We should be entering into an ice age. So this is about 1,000 to 120,000 years ago that we get the last interglaciers. And there is a mid-Holocene, so we should be going into an ice age. Instead, we are not. Our carbon dioxide has been rising sharply. And so instead of seeing a glaciating starting, our Arctic sea ice is actually decreasing dramatically to a very sharp minimum. So huge reduction in the Arctic sea ice volume. And so because CO2 has been rising, and so our carbon dioxide that is induced by human activity actually started from around 8,000 years ago when our ancestors start agriculture activities, and there is the forest clearing. And then 5,000 years ago, there is the livestock start to come into play. And of course, about 100 years or so ago, we start to use fossil fuel. And that is when this carbon emission increased sharply. Instead of going into an ice age, we are actually seeing a lot of changes in the ice volume. So this is an all Antarctic mass loss from the ice shelves. You can see that there's a dramatic reduction. And if you focus on the West Antarctic, there is an acceleration of loss of mass in the ice shelf. So greenhouse emission is actually changing the course of those natural cycles. It seems to be preventing an ice age, but it has increased the carbon dioxide so dramatically that the consequence is very difficult to measure at this moment. So has greenhouse warming affected tropical variability or not? We know that tropical variability that we are interested in and that affects Indonesia and Australia dramatically is the ENSO and Indian Ocean dipole. So I'm going to focus on the Indian Ocean dipole and then talk about ENSO at the end of the presentation. And so here I already talked about the partial Indian Ocean dipole in the 2019 that preceded the huge bushfire 19 and 20 in Australia and Indonesia, and also flooding in East Africa and India. So here will be what I'm going to discuss about today, starting from what's Indian Ocean dipole, how it impacts Australia bushfire, and how it is responding to global warming, and then how ENSO will respond to global warming. So Indian Ocean dipole, we all know, refers to the cooling in the east, accompanied by warming in the west, and it started from those two papers in the same issue of Nature. And really, it's a sort of the nephew of the cousin of the Pacific. It's involved ocean atmospheric feedback. When you have a cooling in the east, it generates easterly wind anomaly that in turn promote warming in the west, promote atmospheric convection, and in turn inducing the wind cools the east by shallowing the thermocline, promoting upwelling, and there is this positive feedback. It tend to develop in June, July, August, peak in September, October, November, and so these are the two seasons where southeastern Australia rainfall is recorded, most of the rainfall, annual rainfall. And when the warming occurs here, it promotes convection and rainfall in East African country, and in some years it also promotes rainfall in India. So as I say, it's a positive feedback. So the haze had huge impact on the population in the region, while the African region had the flood. It impact Australia bushfire by preconditioning the rain season, leading to reduce the rain in the rain season. And in the summer season, December, January, and February, Southeastern Australia is a dry season anyway. So it creates a very dry environment. When the bushfire comes, it becomes much more severe. And the biggest one was in 2009, where in a few hours time, Melbourne temperature went up dramatically because it's been very dry, and it kills many people in a few hours. And those are some of the scenes of the picture. So previous bushfire is in 1983. So in 82, June, July, August, September, October, we also had a positive Indian Ocean dipole event. Now in the 2009, before that, we had 3 consecutive positive Indian Ocean dipole events, 2006, 2007, 2008. And that made that fire much more devastating. And so if we put the major bushfire in southeastern Australia, we see these against the dipole index, El Nino 3.4. You can see that all these major bushfires occurred during positive Indian Ocean dipole events. And it become, as Wednesday bushfire, it's in conjunction with an El Nino condition. But in Black Saturday, actually 2008, 2009 are actually La Nina years. So Indian Ocean dipole had a bigger impact in terms of bushfire in the southeastern Australia, because most of the major bushfire are in positive Indian Ocean dipole years, about half in El Nino, half in La Nina. So in here, Black Saturday, we had, that's 2009, it's actually in conjunction with La Nina. And more importantly, the ENSO's impact on southeastern Australia is conducted through the Indian Ocean. So by affecting the cooling in the Indian Ocean, that cooling generates a low speed wave trend, which has a high pressure in south of Australia, and that high pressure lead to a lower rainfall, push the rain system to the ocean, reduce the intensity of rain, and so in terms of ENSO, it doesn't actually have the pathway to directly impact on southeastern Australia, but it, unlike in Indonesia, it has direct impact. But for the southeastern Australia, it goes through the Indian Ocean. And so Indian Ocean is like a postman to deliver the impact for El Nino to southeastern Australia, leading to dry condition. So in SON, again, you see that that wave trend coming through to South Australia, leading to low rainfall in southeastern Australia. So that's what we call the Eastern Indian Ocean wave trend, and that's the ENSO. ENSO also has its wave trend, PSA and PNA, and Equatorial African wave trend. It doesn't have impact on southeastern Australia. So the only way the ENSO affects southeastern Australia is through this Indian Ocean wave trend. And if you have two combined, then you got particularly in September, October, when El Nino is well developed, you see that the combination of those Pacific wave trend and Indian wave trend, a key to that is still this low high pressure south of Australia. And of course, over the tropical Pacific, you have the convection move away from this region to Eastern Pacific or Western Indian Ocean, where that's why Indonesia experienced drought. Now, on top of the rainfall, usually the high pressure also lead to higher temperature in SON, in soil moisture as well, of course, because you have higher temperature, you have low rainfall, and the memory is very clear in soil moisture. For example, the 6 months soil moisture, upper soil moisture, lower soil moisture below 1 meters, and also in maximum temperature. And that together, low rainfall, high temperature, leading to low soil moisture, precondition, dry condition for the bushfires. Now, 2019 is the second strongest on record. So here is the 130 years of the Indian Ocean Dipole Index, this trended, and this is the SON, just on the peak season. It's the second strongest on record, and it's second to only 1997. So how the Indian Ocean Dipole will respond to global warming is a very important question. So there are some studies which suggest that in the past, we had Indian Ocean Dipole even more extreme than what we have seen. So for example, this is a study by my colleagues, Mallory, which shows that in the past, when the Earth is warm, and we are talking about 6,000 or 5,000, 4,000 years ago, the Eastern Indian Ocean is actually cooler, and those Indian Ocean dipole events, the intensity are actually much stronger than what we have seen in 2009, and more importantly, the impact is it could be very large in the past as well, and during if we go back more recent time from say 2,000 years ago, the Indian Ocean dipole has been becoming quite extreme as well. Looking at here, from the paleo record. So an increase in frequency and strength of Indian Ocean dipole during the 20th century is also seen compared to the early century, because we have the enhanced seasonal upwelling in the Eastern Indian Ocean, and they find that these kind of second 20th century is not actually due to ENSO. It's actually basically the system, the Indian Ocean system, that is changing. In 2013, we were asked to write a review paper, and we look at the 20th century IOD, and this is a time series. And you can see that there is an upward trend in the index, basically the west minus east index. Yeah, and if you just use this law index to characterize the event frequency, the index is greater than 0.75 standard deviation, you will see that the frequency has been increasing from about 4 or 5 events per 30 years in early in the century to something like 10 in a century. But if you detrend them, if you detrend this time series, the frequency increase is much less. So the mean state change seems to be projecting onto this extreme, into these kind of climate events. So using CIMIT-5 and CIMIT-6 model, there are a couple of studies suggesting that there's no statistically significant change in the DMI. Multimodal, there are more models showing an increase, showing a reduction but the change is very, very small. So here are some of the model in the standard deviation of DMI, dipole mode index in selected models. And so you see, well, the intermodal, the multimodal ensemble average. So the present day, future, and these are reduction in the frequency, in the standard deviation, in the standard deviation, but there is no intermodal consensus. And if you look at the changes in standard deviation without selection, again, you got half and half, and there's no multi-model average. There's no change in no significant change in the multimodal ensemble average. Now, these kind of analysis just take the index without separating extreme from moderate events. So if we focus on the extremes, we actually could see a different change. For example, if we look at extreme rainfall impact events, here we are comparing 1982, which is a mild, moderate partial Indian Ocean dipole event. 1997 is a huge partial Indian Ocean dipole event, and the pattern is quite different. Much wetter in the Eastern African countries, much drier in Eastern Indian Ocean, in Indonesia as well. We know that events. And these easterly winds extend further towards the west, pushing warm anomaly to the west, leading to more rainfall in East African countries. So we can't actually use an index, just one single index, to describe IOD. We actually have to use two indexes to tell the difference between these two patterns. Because if one index is sufficient, then this pattern should be the same. So we use a combination of two rainfall patterns from an empirical orthogonal function analysis. And so these are the two rainfall patterns associated with wind. So you can see the second pattern give you this further extension of rainfall in African countries, pushing the dry condition along the equator and leading to more reduction in rainfall in this region. So a combination of these two, for example, the associated time series, principal component 1 and principal component 2, give a nonlinear relationship, and it automatically identified the three known huge up to then, without the 2019, the three large events of 1997, 1994, and 1961. And so this first principle really corresponds to the dipole mode index. So if you replace this first principal component index with the IOD index, DMI, dipole mode index, you get a similar relationship. And so this gives us a way of telling extreme events from moderate events. So we are going to use this. So this is 2019 in this picture edit. We are going to use this method to identify IOD, extreme IOD in the present day and in the future. And present day is taken as this period. We got 23 phi model. Each has 200 years over this period, separate into two sub-periods, and then we can compare the frequency. And now you can see that in these models, in the present day climate, the frequency of extreme IOD increases from 17.3 years to 1 in 6.3 years, so more than double the extreme events. And 21 out of 23 models are showing an increase. So while we are not sure about how IOD index using temperature index will change, if we use extreme rainfall as our measure of impact, those extreme events, are going to increase dramatically under a huge climate. Now, this is the business as usual emission scenarios with very strong intermodal consensus of the increase. And the dynamic is reasonably simple. Under climate change, this is the mean climate. The east is warming less, the west is warming faster, and so those atmospheric convection, which tend to follow where the maximum temperature is, tend to more easily to move away from the eastern Indian Ocean, because the west and the north are warming faster. And so the question is, could Paris Agreement make a difference? So here we look at an emission scenario, RCP 2.6, which take us to the Paris Agreement's target, or more or less. So here are from 13 climate models, forced with these scenarios, taking us to 1.5 degrees C by around 2030, and by about 2050, it took us to a bit less than 2 degrees relative to global warming. And so we have we had a temperature in black color, average over those 13 models, stabilizing. And here are the 30 years sliding window of frequency from those 13 models. And the average is in solid line. So the frequency increases with global warming. But once you stabilize the temperature, global temperature, through Paris Agreement, the frequency tend to also stabilize. Now you're not hearing this talk today. I forgot to delete that. So from past to future, that I took you this journey of the temperature in the planet Earth. Now 120 maybe 60 million years ago, this is the temperature. Now, if we, with our carbon dioxide, without emission, without mitigation, following the business as usual scenarios, it's going to take us, our temperature to that of 50 million to 60 million years ago. In a very short period of time, the climate system's carbon dioxide in a natural cycle could accommodate 100 ppm, but in about 100 years' time, we have pumped 150 ppm to the system, and that is continue to increase if we don't have any mitigation. And so I'm not sure in whether what we are seeing, the climate model is telling us, is the real consequence or not, because the speed of the increase, the pace of the increase of carbon dioxide is really unprecedented. And so basically, these are the message that I try to deliver. Is greenhouse warming inhibiting next ice age? Seem to be yes. What is a positive IOD? It's a precondition of the bushfire and cause of bushfire in Australia and Indonesia. How does it impact on Australia? We know, it's dry and hot in rain season. How will IOD respond to greenhouse warming? It would be causing more extreme positive Indian Ocean dipole events. Now, I also have the ENSO, but I think I have run out of time. So basically, the similar story holds. Under climate change, you are going to see extreme Indian Ocean, extreme El Nino, extreme La Nina, frequency increases. And now with IPCC's CIMIS 6 model, that kind of conclusion is even more adamant and more conspicuous. So thank you very much. I'm happy to answer questions.
Thank you, Dr. Menjuchai. So we will hold for the question and answer session after talk from Dr. Miyazawa. But it is nice to hear your presentation. So as we all see, we have seen so many shocking news these days due to the COVID-19, and now we even hear from Dr. Wenju Chai that we're supposed to have ice age, but now in fact we have a warming event. So yes, we will continue for the discussion. So for participants who wants to raise a question, you can hold your question. You can interact directly with Dr. Wenju Chai, or you can type your question in the chat box. So we continue to the next keynote speaker, Dr. Yasumasa Miyazawa.
A researcher of Japan Agency of Marine Earth Science and Technology, JAMSTEC. Thank you very much for inviting me here. I'm much honored to provide my talk at the 3rd International Conference on Maritime Science and Advanced Technology. Here, I will be talking about our research experiences on ocean forecasting and its comprehensive applications. To understand the predictability of the ocean current variations around Japan, we have conducted Japan Coastal Ocean Predictability Experiment, JCOP, with support from JAMSTEC. The main tool of JCOP is data assimilative ocean general circulation models. Our OGCM has been developed with a basis of the Princeton Ocean model. Our group is operating series of ocean forecasting models. One is a semi-global model covering the world ocean, excluding the Arctic seas, with horizontal resolution of 10-kilometer grid. This panel shows a snapshot of the ocean currents and eddies. We see major currents in the world ocean: Kuroshio, Gulf Stream, Equatorial Jet, Circumpolar Current, Somali Jet, and Indonesian through flows. The existence of oceanic eddies is quite ubiquitous. We have number of regional oceanic models, Northwestern Pacific model, and its downscaled version with horizontal resolution of 3 km to 1 km. Some regions of a special interest are modeled with much higher resolution, for example, 200-meter interval. This figure shows a zoom-up view of the Kuroshio south of the Key Peninsula, as shown here in the large-scale views. Now again, we see more smaller scale eddies around the Kuroshio. Our ocean is a typical example of the turbulence. To intensively examine roles of the mesoscale eddies in the Kuroshio dynamics, ocean data assimilation systems based on the OGCMs have been developed. Operational data assimilation system could be utilized for investigating the effect of the initial condition representing the eddy distributions on the resulting evolution of the model dynamics. For example, a data assimilation system has demonstrated the direct trigger of the Kuroshio large meander in 2005 was a warm eddy propagation from the East China Sea. At the present time, the Japan Meteorological Agency, Fishery Research Agency, and JAMSTEC are conducting the operational ocean data assimilation and the prediction of the ocean current variations around Japan in near real-time basis. The predictability limit of the Kuroshio path variation is considered as 1 month. Using our product of the ocean current forecast, we are developing some social applications. By collaborating with a venture company originating from JAMSTEC, we are providing our ocean current forecast information in near real-time basis through distribution of tablet devices to domestic ship companies. The use of ocean current forecast actually contributes to ship routing that allows effective reduction of the fuel usage and resulting CO2 emission. Other ongoing applications could contribute to fishery, marine leisure, ocean drilling, search and rescue, and development of ocean renewable energies. The recent enhancement of the computational resources indicates possibly 2 directions of the ocean forecasting: ensemble and downscaling. The ensemble simulation is utilized for estimation of the uncertainty included in the our ocean forecast, and also utilized for improvement in data assimilation itself, and indication of forecast sensitivities utilizing coarser grid models. The downscaling is necessary for answering an important open questions: open ocean and coastal current interactions. Motivated by recent progress of the computer facilities characterized by the perceptual increase in the number of available computer processors, significant efforts have been made to develop ensemble-based modeling techniques that are highly efficient in taking the full advantage of the massively parallel architectures of the modern computers. First of all, the model ensemble is utilized for estimation of the uncertainty in the model forecast. Recently, we have developed a probability forecast model of the Kuroshio large meander using a machine learning method. Each probability of each meander type is easily distinguished from the model ensembles, as shown here. The second, the ensemble information is utilized for improvement in data assimilation. By utilizing the ensemble information, the 4-dimensional cost function is minimized even without use of the additional tangent linear models. The 4-dimensional variational framework is used for extracting the time-dependent information from the available observation data. This figure compares the first guess and modified initial conditions using the 4-dimensional ensemble data assimilation method. Improved condition is more similar to observations like as shown here. The third, the ensemble information is utilized for detecting the forecast sensitivity from the initial conditions of the forecast. This method is still under development using an idealized model, for example, Lorentz 9060 model. A preliminary experiment as shown here demonstrate that the target observations might be quite useful for effectively reducing the errors. To elucidate detailed open ocean coastal sea interaction processes, we are developing downscaled model structures. Minimum 200-meter grid is a final target of our downscaling development. The further developed smaller scale deviates from the geostrophic ocean dynamics regimes targeted by us and dominated by the surf zone dynamics. Now we are going to local life scale 200 meters. The 200-meter grid is approaching to the sea in front of human life. As we can see, the downscaled model grid actually indicates a local view shown in the real pictures depicting a view along these directions. An important unresolved problem is the dynamics of the closure intrusion into the coastal regions. We require a higher horizontal resolution of both of the with increasing the horizontal resolution and could affect the warm water intrusion from open oceans. Remote sensing from space is much effective. However, the satellite measurement has some difficulty in detecting the oceanic conditions. The sea surface temperature measurement allows high-resolution observation, but it is significantly contaminated by atmospheric clouds. The satellite altimeter measurement through microwave is not affected by the clouds, but it is in line tracking of ocean and has a horizontal gap of measurement. This figure shows the observation track of the altimeter satellite in 1 week period, involving relatively large-scale gaps. International collaboration achieves a combined use of the 3 satellites, JSON-2, Cryosat-2, and Solar Arctica. But still remaining gaps could cause failure in detecting eddies inside the gaps. To compensate the remote sensing observation, we are developing a sustainable field of ocean monitoring scheme through utilization of a feedback mechanism between users and ocean forecasters. A higher resolution ocean modeling requires more dense observations with higher frequency sampling in the nearshore areas. Now, some of Japanese oceanographer groups, including JAMSTEC, are constructing a feedback system connecting the modeling and observation toward enhancing the observation measurement sampling in the coastal areas. The oceanography farm groups provide fishery and shipping people with their forecast products, and the users, stakeholders, provides their own observation data to the oceanographer groups. They provide the forecast product with improved skills by assimilation of the user's data to the users. The improvement skills of the forecast products strongly motivate the users to enhance their observation activities. Such feedback mechanism is helpful to sustain and enhance the observation system around the coastal areas. This slide shows comparison of the ocean current estimation using our ocean forecast system without and with assimilation of ADCP ocean current data around Tosa Bay in south of Japan. The observation data were obtained by the local fishery research agency of Kochi Prefecture by assimilating the data provided from the local stakeholders, the localized coastal currents, which might be not captured by the remote sensing data alone, are reasonably represented as observed. We transferred our forecast with the improved skills to the local fishery stakeholders. We need to enhance in-situ measurements by closely collaborating with the local stakeholders. Development of advanced biogeochemical modeling based on the advanced physical modeling is our next target. This is necessary for elucidating the material circulations and closing their budget between the land and oceans. Now we are developing a relatively simple eco-carbon cycle model that is composed of an NPZD ecosystem model and a carbon cycle model. Our first target is investigation of the effect of the ocean current variability on the NPZD ecosystem and carbon processes. And eventually, coastal processes, including the river discharge and human effects, could be added to our modeling. The marine environment is significantly changing at the present time. For example, around the Japan coastal ocean, the marine heat waves frequently occurs. The last summer, of Hokkaido Island, a lot of Japanese sardine died owing to the lack of oxygen. This is an unprecedented event that has never occurred in this region so far and could be related with marine heat waves. To elucidate the responsive mechanism in detail, we are modifying the marine ecosystem model coupled with our ocean forecast models to include oxygen processes. Summary of my talk is here. The ocean forecasting and its applications could be an effective tool for advancing operational oceanography because it provides the information on the predictability of the targeted phenomena, and it provides the information contributing to various kinds of practical social applications. And also, it provides the information about the optimal design of the observation network. The biogeochemical application is the next target of the ocean forecasting. We are every time welcome to have any kind of international collaboration for advancing operational oceanography utilizing ocean forecasting together. Thank you for paying attention. Thank you very much.
Thank you so much, Dr. Miyazawa. So we just listened to the presentation of Dr. Miyazawa, and I need to inform you that Dr. Miyazawa has a long story to his employment at JAMSTEC. He's now currently has been appointed as a deputy director in application laboratory, one of the famous group in JAMSTEC, in which I also have experience to be there. And he also active in many international scientific communities, such as famous international workshop on modeling the ocean, training course on ocean modeling by UNESCO IOC, and he also associate editor at JGR Ocean, and also active in community services such as scientific reviewer in many ocean journals. And most importantly, he is a key scientist behind the Jacob model, the ocean model used to predict meandering and other coastal ocean dynamics such as mesoscale eddies. So it is nice to have you with us today. So we will start our Q&A and also discussion. We have at least 1 hour to have discussion. For those who would like to raise a question, you can mention to whom you would like to ask your question. You may also turn on your camera, and I wish I have time to ask a question to but anyway, yes, please, from the audience, I would like to give first opportunity to Professor Ishak Iskandar. Please, Pak, you may ask your question.
Thank you, Pak RK, for the time. So it's nice to be here. So I am enjoying the presentation by Professor Wenju Chai and Professor Miyazawa. I have a question about the presentation from Prof. Wenju Chai. So from your presentation, you mentioned that there is a tendency for the extreme positive Indian Ocean dipole to be occur in future. So the question is, so the definition of the extreme is, if I'm not wrong, so it's when the DMI is exceeding 0.75 of the standard deviation, you define as the extreme IOD event. So how about the length of the events? Is that any change in the length of the event? It's become a prolonged IOD or just short IOD? And also the type of IOD, the positive IOD. As we know, we have now we have two type of positive IOD: the typical IOD and then the central IOD, like in El Nino. Is there also change in the future for this type of positive IOD? So this money
is not the 0.75. It's actually in if I can show you my presentation again, it's when I do 0.75, I just look at all IODs. But for the extreme, I use the combination of the two patterns. Let me share my screen again, if that's okay. Is that okay?
Sure, sure.
Yeah. Right. So can you see the screen? Yep. You can see the screen, can you?
Yes.
Yeah. Okay. So the extreme IOD is actually the combination of these two patterns. Combination. Let me show the next one. The combination of the next pattern. Let me show. Okay. Here. Yeah. So the combination of these two rainfall pattern, and so when this is greater.
Screen. I'm sorry.
Can you see screen?
I cannot see.
Yes, we can see your screen, but can you put in slideshow?
Yep.
Yes.
Yeah. Okay.
Now, so so you can see that this is using rainfall pattern to look at the extreme. So if you have this rainfall pattern superimposed on this rainfall pattern, so both are positive. So this is the second one, greater than 0.5 standard deviation, and the first one greater than 1. You pick up those extreme events. You pick up those extreme events. That's how initially we use that to define extreme positive Indian Ocean dipole events. And these kind of events increase in frequency by a factor of nearly 3 times if we don't have any mitigation in the emission. In the emission. And so, they recently, this is using rainfall in the definition. So in basically very dry condition in Indonesia, wet condition in the African country region. But recently we have another paper coming up, just appeared in Nature Climate Change, which we now use SST. If I can show you a picture, and maybe you can still see in the screen. This is operating while you are asking question. Let me click this one. This has already appeared in Nature Climate Change. So if we look at sea surface temperature in terms of again the combination of these two. So this is this is the EOF1, the dominant pattern, and so basically this is very similar to DMI, cooling in the east and warming in the west. But there is another pattern, and so here you can see that the cooling, the subsurface cooling, reach to the surface, leading to this cooling, and this extreme Indian Ocean dipole event in temperature. Those are the extremes, are the superimposition of these two. Right? So you can see, if I make it a bit smaller, you can see the whole screen. So this is, so basically this pattern.
Sorry, Prof. Wenjuchai, I cannot see the change in the screen. I'm sorry. I mean,
you can't see the screen?
Yeah, only show the last screen only. Maybe there is no change in the screen. I mean, you show different screen, I think.
Yeah, I think due to different set of monitor. So it's, if you don't mind, you can put in slideshow many.
Oh, okay. I can put
with many
inside
types of computer. Yes.
Oh, okay. Sorry, I can do that. Very easy. Yeah. So I can do that easily. I can do put this in the PowerPoint, right? Yeah.
Yes.
Okay. Let me put it there. Let me put operation straight away. Yep. New slide here. And then I can put in a show, huh?
Yes.
Yeah. And let me just grab one more picture to show the result. Just one more picture. Yeah. So this, and so we can, so I don't have to do this again. Yes. And then I put in the show. Sorry, next slide. New slide. Okay, now I can talk now. All right, let me put on the show in here. Yep. Now can you see?
Yes.
Oh, okay. Yeah. So I used rainfall previously, and now I'm going to use the temperature, right? So an extreme event is really the superimposition of this pattern. So here is the time sequence of this pattern, PC1, the principal component, and this is a PC2. And again, they show a nice nonlinear relationship. And so these are the extreme events of the Indian Ocean dipole 2019 here, right? And so we can use these two patterns to construct an extreme IOD index. So extreme IOD index will be the sum of these two. And the moderate IOD will be the difference of these two. So if you have a moderate, you get that there's cooling in the east. Yeah, just this one minus that one. And so, yeah, so this is the extreme part Indian Ocean dipole, and this is the moderate Indian Ocean dipole, and you have that index. So extreme, S extreme is this observation, and the green is this moderate index, and this is the DMI index. So it split the DMI index into two categories of extreme and moderate events. And then we look at climate change period. Similarly, we compare the first 100 years and the second 100 years, and look at how they change in the standard deviation. So this is the moderate index. And so most of the model showing a reduction in the variability, but this extreme showing an increase. 22 model here or something, only 3 showing a reduction, majority showing an increase, and the multi-model ensemble also showing an increase. So in a climate change world, we are saying that you are seeing more extreme Indian Ocean dipole events, but less frequent, moderate Indian Ocean dipole events, even if you use sea surface temperature index, and that is actually similar to what we are seeing here using rainfall. So those are the extreme, and these are the moderate in the present day climate and in the future climate, right? So similarly, you are seeing whether you are using rainfall or you are using sea surface temperature in a warming climate, the extreme positive Indian Ocean dipole events increases in frequency. And you can see in this picture, in terms of rainfall, the intensity is also increases. It's these a lot bigger value that you don't have here. You don't have here. So so basically that is the upshot of how Indian Ocean dipole, positive Indian Ocean dipole event may respond to climate change. Now I can show another picture of the extreme El Nino, but basically what happened is that extreme El Nino also increased in frequency by about doubling, and extreme La Nina also increased in frequency by about 75%. And the Central Pacific El Nino also increased a little bit, but not as much, because basically the extreme El Nino tend to occur in the Eastern Pacific. And when you have extreme El Nino, you tend to shallow the thermocline, and that is good for La Nina to follow. And that's basically extreme La Nina also increase in frequency. But the moderate El Nino, the frequency doesn't change much. Does that answer your question?
Yes. How about that, Professor Ishak Iskandar? Is that answering your question?
Yes. Thank you very much, Prof.
Okay. Thank you so much. So next we have a question for Dr. Miyazawa. We received question in our chat box. Okay. Let me read.
Can I reply? Can I reply to the
Professor Ishak?
Yes.
This one is the question to Dr. Miyazawa. So wait, we still have a delay here in my monitor. For the okay, I just read the question for Dr. Miyazawa. For country like Indonesia, how important to have ocean forecast system? So if government don't much care to ocean forecast system, what will happen to Indonesia?
Yeah, this is an important question. I have never considered the government could ignore the importance of the ocean current forecast information. Maybe we can show a good example for demonstrating effectiveness of the ocean forecast in the Indonesian regions. Maybe search and rescue. And then this morning, some accident of the airplane is reported in the TV medias. Maybe search and rescue with utilization of the ocean forecast could help to searching of the accidental people in the oceans.
Okay. Thank you so much. Yes. So in this MSAT, we have many teachers coming from Pangandaran. So yes, perhaps they want to know about the ocean forecast system, how it is important to for the Indonesian. And I think we have another question for Dr. Miyazawa. Okay. How Jamstack can convince the industry to use ocean prediction for their activity? And when the industry collect the data, who provide the instrument? When they share data, what benefit they get?
Okay, Jamstack facilitates the operation of the venture companies with support of the Jamstack. Maybe venture company is very important to create the communication between the ocean prediction and especially commercial users. And in the instrument distribution have many options. Sometimes we Jamstack will provide the payment for purchasing the instrument, and also the user themselves are very positively purchasing instrument by using their budget. That's interesting.
I see.
Yeah.
Yes. That's very
because
interesting.
they actually have importance of the benefit by receiving the improved forecast, including their own data. Yeah.
Okay. So I think that question is trying to ask if they share the data, what benefit they get. Do you have any comment? For instance, if they share the data, do they have perhaps here is a fee reduction from purchasing Jamstack data?
Yeah. Maybe benefit itself is improved skills. In my experience, user requires a very skillful forecast. Not a skill forecast is not interesting for them. Just skillful forecast is important for our users.
Sure. Okay, thank you so much for the answer. Is there any question? Here's for Dr. Wenjuchai.
Yes.
Recently, last week, Joe Biden predicts Jakarta will sink in 10 years. This one is quite famous news in Indonesia. So here, do you think IOD El Nino helps with the reduction of sinking of Jakarta?
Are you saying about sinking of Jakarta because IOD is lower the sea level rise locally?
I don't know here.
Because we had a cooling in the eastern Indian Ocean. So yeah, depending on what do you mean by sinking of Jakarta. Yes, IOD and El Nino is not helping in terms of drought and bushfires. And given that they are becoming more extreme. So it can only not help rather than help. But if you think that El Nino and IOD is causing cooling temporarily for a few months in the eastern Indian Ocean, which could potentially lower sea level, maybe. But
Okay, anyway, thank you so much. So from the floor participant, I saw before Miss Putri Adia or Mas Faisa Amri were raising hand. Yes, to Ibu Putri Adia, you may ask questions.
Yes, could I speak
Hi.
now? Yes.
Yes, of course.
Hi. Good afternoon, ladies and gentlemen. Let me introduce myself. My name is Putri. It's a great topic from Sir Wenju Chai and Sir Miyazawa. And I have a question for Sir Wenju Chai about the extreme positive Indian Ocean dipole, which is characterized by which is every phenomenon of positive Indian Ocean dipole has unique features than others. And my question is about what is if I'm not mistaken that the thermocline warming is one of part which is contribute to the extreme positive Indian Ocean dipole in 2019. Could you explain me about the mechanism about the thermocline warming? That's my question, sir. Thank you.
Yeah, very good question. Yes. So we know that in a big scale, just reduce the Earth into a vertical column, global warming resulting from increasing carbon dioxide. You can imagine carbon dioxide as a layer of a blanket, and just so covered, and it keep things or the atmosphere and the ocean under the blanket warm, just like when we cover ourselves in a blanket or in a glass house. So if the sunlight comes in and you come to this glass house, and the glass house just covers it and preventing heat from escaping from the glass house or greenhouse, and so it makes the air inside the greenhouse warmer. But this is a very simple sort of a starting point. So the Earth's climate, the system has circulation, and so it's not warming evenly everywhere. And so that uneven warming, because the temperature, the climatological temperature is not even either. For example, in Eastern Pacific is cooler than Western Pacific because of the circulation, because of the trade wind which blow warm water from Eastern Pacific to Western Pacific, and that generate a gradient between the West and East. And in the West, when temperature is so warm, it promotes convection, evaporation, generating a lot of cloud. And so when the air rises, the wind in turn drive more air, more flow, more surface warm water from east to the west, and that wind also drive cool upwelling in the east, and so you have all this gradient. And so because of that, the greenhouse warming will not lead to the same amount of warming everywhere. In some places, it enhances the existing gradient difference in temperature, but in other places it offsets, and that leads to circulation changes. So, what, how then greenhouse warming influence the response of Indian Ocean dipole, because in the east it's warming less than in the west. And why in the east it's warming less? Because in the east, during the southern winter season, or spring season, June, July, August, September, and October, the climatological wind is easterly wind from east to west. And that drives upwelling, cold water from ocean to surface. And that maintains a little bit of temperature gradient from west to east, cooler in the east. So under global warming, the east is warming less than the west. And so even if everything is the same, the variability is the same, rainfall is easier to move to the west because the west is slowly warming a bit faster than the east. And that basically affects the Indian Ocean dipole. It makes extreme Indian Ocean dipole easier to occur because rainfall is convection is able to move to the west a little bit easier. And so that's how things changes, because it doesn't warm evenly everywhere under greenhouse warming. Does that answer your question?
No, sir. Thank you. That's a great answer. I think it's enough.
Because yeah, I can talk more if you want me to. Just
Yes.
Thank you, Ibu Putri. Thank you so much.
You're
So I
welcome.
think Pak Faisal Amri wrote a question in chat box. If you don't mind, you can ask directly to Dr. Wenjuchai and also to Dr. Miyazawa. Please, Pak Faisal Amri.
Ya, makasih banyak Pak RK. So, thank you for the talk, Dr. Wenjuchai and Dr. Miyazawa. So, I just read my question for Dr. Wenjuchai. My question is, does the Indian Ocean also exhibit unique linear long-term trend like the cold tongue mode in the Pacific Ocean, which possibly affect the IOD flavor in the future? And for Dr. Miyazawa, although you may already answer, but I just read it again. Does the current downscaling scheme applied in Jacob allow relatively local scale circulation to interact with large scale circulation in the coastal grid? Yeah, that's my question.
Yes, perhaps Dr. Miyazawa can answer first Amri's questions.
Okay, this question is related with the selection of the two-way and one-way nesting schemes. Now we are adopting one-way nesting. Just outside model affects the inner models. Maybe physical model is okay, but in the near future we are considering to develop the biogeochemical model. Maybe biogeochemical model requires such kind of interactions, especially for closing the material budget between the coasts and open oceans. Yeah.
I see. Thank you for your clear answer. So next to Dr. Wenjuchai about Faisal Amri's question.
Yeah, very good question. Yes. Let me show the screen again, if you don't mind. I think the quick answer is that Indian Ocean is actually showing a little bit of trend in the long term. And let me see let me show a slide again in here. So can you see my screen?
Yes.
Yes. So here, for example, if we look at the observation, so this is the zonal SSE gradient. It's actually the west, take away the minus east, west minus east. So you can see there is an upward trend, and that's indicating that the west is warming faster than the east. And that is precisely what climate models are projecting into the future. Yeah. So we are seeing those. Now the question is one reason for it, one possible way of this trend that could affect the cooling in the east, making Indian Ocean dipole more extreme, is, for example, if you have this faster warming, then the easterly wind, because the easterly wind along the equator is driven by temperature gradient, the easterly wind will be greater, right? Now, if easterly wind is greater, then evaporation will be stronger, and that would lead to a cooling when IOD is developing, a bigger cooling, and therefore intensifying the extreme positive Indian Ocean dipole events, which is basically a cooling in the east and a mild warming in the west. So that is one way. But in climate model, it is really when the Eastern Indian Ocean dipole is cool enough, it will suppress the rainfall, and so when it is so cool, imagine there's no more cloud, and cloud tend to be damping. Cloud tend to block some of the sunlight, so be damping the cooling, right? So no more cloud, and that would allow cooling to really develop much stronger and therefore more frequent and stronger positive Indian Ocean dipole events.
Okay, so Professor Wenjuchai,
yeah,
I'm very much interested with Amri's question, but here I would like to focus on the linear issue. We often see, or we often analyze the IOD based on linear correlation,
right?
Positive minus negative, and here you shown that the shift or the change in climate. Do we need to move from the linear terms into, let's say, non-linear analysis? Okay.
Yes, I actually think so. I think some of our research work that get to all those journals is because we move away from linear framework, because nonlinear dynamics is very important here. So, for example, I show here these two patterns. Sometimes it occurs as a superimposition. Sometimes they occur into offsetting to get those moderate events. So it is not necessarily a linear sort of dynamics. In fact, there is a nonlinear dynamics here. Once you have a cool anomaly developed there, once it's big enough, it generates this easterly wind anomaly, which will generate oceanic current anomaly. And so the nonlinear zonal advection become very important, reinforcing it. And so it really gives you this. I mean, if you do a correlation between all these points, you will get a positive correlation. But they are not linear, they are actually nonlinear. So while linear dynamics may capture some of them, but to be precise, in order to tease them apart, you actually need to use nonlinear, right? So nonlinear is when the core anomaly grow into big, it become much bigger because it's superimposition of the two. When anomaly is mild, it's the difference between those two that make a moderate positive Indian Ocean dipole events. Yeah. So nonlinear dynamics is actually key in order to understand the IOD and ENSO response to climate change. So I actually point out a couple of slides where I was going to show the nonlinear as well, similar thing, but let me just show here. For example, for El Nino, if we actually have to use a nonlinear too. So this is the first principal component, basically. Warming in the eastern and central Pacific. Second component is the cool in the west, warm in the center, and cool in the east. And you can see they are, again, very nonlinear, right? And so in models that are able to capture this nonlinear dynamics, they are much better in terms of simulate the change. So for example here, are the 17 models that are able to produce the nonlinear dynamics and the standard deviation of ENSO in present day climate in blue and in the future climate in red. And you can see now you've got a very strong intermodal consensus of increased variability. And here are the strong extreme El Nino, Eastern Pacific El Nino events, the frequency. Again, you got most of the models showing an increase, more than 50% increase using sea surface temperature. This is a paper in Nature in 2018. So nonlinear, able to capture this nonlinear dynamics is actually very important. Yeah.
Okay. Yes, it's also. I'm very much interested to ask more questions. But is there any question from the floor? You may raise your hand, or while waiting, following up your answer. As a physical oceanographer, we are very much interested in understanding the predictor. And for area in Pacific, we have so many how to say a diversity of ENSO. So it's difficult to learn. It's not possible, but it's since the basin is quite big and so has so many diversity. Looking to the predictor, it's quite hard, and actually it's part our duty to find correct predictor. And for the Indian Ocean, do you think the diversity of IOD also exists? You mentioned about the how to say the more than one. Yeah. So, but when we relate to the concept of the diversity of ENSO, does it apply also to IOD?
Precisely. Yes, that's again very good question. So here, can you see my screen? Yeah. Can you see my screen?
Not yet. Not
oh,
yet.
so let me maybe I did not share. Let me share.
Okay.
Let me share screen. I'm again going back to the so you can see my screen now, I think. Let me put on the show. So in the Pacific, we have the Central Pacific El Nino, we have the Eastern Pacific El Nino, and Eastern Pacific El Nino tend to be a huge El Nino. Central Pacific tend to be more mild. And so here we are looking, we use two indexes. We split the dipole index into a strong and moderate index. And so these are the moderate IOD events. So the moderate IOD events tend to have mild cooling in the east, but stronger warming in the west. By contrast, the strong IOD events, the red, tend to have very strong cooling. Was able to get this subsurface temperature to influence and then extend along the equator to west, pushing warm anomaly. Yeah, but there is also this diversity. And so now the simplest way is just two kind of IOD. But in here, you can see they are reasonably separating from each other, quite distinctive. this group, and so that is the composite, the composite anomaly for this group, and those are these are the composite, and you can see that just like Pacific processes. So in the processes, so in this moderate one, the subsurface ocean is not as involved as in the strong one, and so now prediction is very important. The Indian Oceans, the lead time is a bit shorter, simply because we don't have like warm pool, distinctive warm pool, because the thermocline is reasonably flat, and so there's no warm pool movement in that. But I mean, in the Japan group, Dr. Miyajava's group, they had a very nice model which could predict Indian Ocean dipole very well, and also the interaction with ENSO. Yeah. Now for ENSO prediction, I think once we get through the predictability barrier in May, after we pass May, I think we win the heat content as a predictor, and maybe the Indian Ocean's memory of the capacitor effect. Once we take those into account, at the moment, I think there's 6 to 9 months of predictability, I think. Yeah.
Okay, thank you so much. I would like to ask one more question last question to Miyazawa, to Dr. Miyazawa. So after hearing the explanation of Dr. Wenju Chai about the complexity of Indian Ocean and also the Pacific Ocean bit, for the Jacob model or even the FGO model, is it able to reproduce such kind of complex interaction in the model? And for the modeler, what is the quick win for you to how to say that this the model that you develop is good? Because we have seen in many climate model, they have so many different results each other. But from your experience as modeler, what is the quick win looking to very complex physical oceanographic process in Indian and also in Pacific Ocean?
This is a very important question. But regarding the prediction of the Indian Ocean dipole, our group of Jamstack is introducing the effective assimilation of the subsurface informations, not only SST but also subsurface hydrographic information around the, especially around the Java Sea is very important. In terms of this view, in sheets hydrographic subsurface informations, observations around Indonesian region is very important to create a more accurate IOD forecast.
Yes, thank you so much. So with that, oh yes, please.
Could I ask Dr. Miyajava a question?
Yes, please.
It's great talk, Dr. Miyajava. Yeah, you talk about the heat waves. Is it important to have very high resolution in terms of simulating marine heat waves?
Yes, marine heat wave could created from the both atmospheric and also marine heat wave also related to the internal oceanic processes. Maybe horizontal scale of internal processes are quite smaller as compared with the effect of the atmospheric forcing. maybe detailed processes of marine heat wave is related to the internal oceanic processes with more smaller scales.
Uh-huh.
Yeah.
Okay.
Okay, thank you so much for the clue. Yes, and I think we have 5 minutes to prepare to the next parallel presentation. With that, I would like, or we would like to express thank you to Dr. Wenju Chai and also to Dr. Yasumasa Miyazawa.
Thank you very much.
As a keynote
Thank
speaker
you.
in our presentation.
Thank you for having us, or
We
having
hope we
me.
can see you. Yes. With this, I would like to end this keynote session, and we can move on to the parallel session. Thank you so much.
Thank you.
Thank you very much.
Thank you. Bye.
Bye.
What a very interesting discussion. It was very, very exciting for us all to listen to both experts, right? Okay, well, now we will move on to the second parallel session. We have provided 4 breakout rooms for each session. We kindly invite the speakers to the designated rooms and participants to join the room of your choice. Room A holds a mini symposium titled Ocean Atmosphere Dynamics and will be moderated by Siswanto PhD. Room B holds a mini symposium titled Marine Resources, Conservation, and Integrated Coastal Zone Management and will be moderated by Dr. Rima Rahmayani. Room C holds a mini symposium titled Marine Hazard and Coastal Degradation with the Issues on Marine Debris. And this mini symposium will be moderated by Dr. Eng Toto Supriyo. Room A holds a mini symposium titled Marine Resources, Conservation, and Integrated Coastal Zone Management on Ecotourism and Conservation. And this room E will be moderated by Dr. Ankik Taufikur Rahman. Ladies and gentlemen, please be advised regarding the rules for joining this session as shown on your screen. For more detailed information, please check our website. You can rename your Zoom name with room of your choice _ and your name. Room of your choice _ your name. You can rename your Zoom name. The committee would be at your service in the Zoom main room to ensure the programs go well. Should you encounter any problem, please contact us. Please be reminded to go back to this main room at 5 p.m. Western Indonesia time. Thank you.
Recording in progress. Recording in progress. Recording in progress.
Pak Siswanto, apakah sudah hadir, Pak? We are waiting for the moderator for this mini session. Pak Siswanto. Pak Siswanto, bisa dimulai, Pak? Oh iya, terima kasih banyak, Pak. Silakan, Pak.
Okay, hello everybody, dear participants. Now we are in the room A. So we have the topic, the ocean atmosphere dynamic, in particular for IOD and its interaction. We have about 7 speakers here, and we're going to start with the invited speaker, the presentation from Dr. Agus Santoso at first. So I hope that Dr. Agus Santoso already present in this room. Okay, thank you very much. So Dr. Agus Santoso is a senior research associate at the Climate Change Research Center in Cisairo Young Science Leader. He was awarded a PhD in the University of New South Wales School of Mathematics and Statistics. His research aimed to unravel the mechanism of the governed climate variability on seasonal to centennial time scales. So it's also including the El Nino Southern Oscillation and Indian Ocean Dipole. So many drought and flood episodes in Australia have been attributed to ENSO and IOD. And Dr. Agus Santoso is an associate investigator at the Australian Research Council Centre of Excellence for Climate Extreme. So here, Dr. Agus Santoso will present his lecture in ENSO and IOD in climate models and investigation for the future projections. Please, Pak Agus Santoso, if you are ready, time is yours. You have 15-minute presentation, and then we're going to have a 5-minute question and answer. Are you ready there?
I uploaded my video.
Okay, yeah. So the team will play your video, and then we continue with the question and answer afterwards.
Okay, thank you.
Please, technical support.
Warm greeting, and I wish everyone is well. I'd like to thank MSAT organizer for this opportunity. My topic today is El Nino Southern Oscillation and Indian Ocean Dipole in climate models, and what it means for their future projections. At the end, I will briefly discuss the implications on Indonesian through flow. This presentation highlights various recent papers, most of which I was involved in. ENSO and IoT have significant impact on climate, particularly over the Indo-Pacific region. ENSO and IoT also impact on ocean circulation. As the water circulation weakens during a positive IoT, leading to a drier condition over Indonesia and Australia, as atmospheric convection shifts westward, the thermocline shoals in the eastern Indian Ocean, leading to lower sea level than normal. Because of this, the Indonesian through flow, an ocean flow from Pacific to Indian Ocean, is increased. On the other hand, the through flow is reduced during El Nino, as sea level in the Western Pacific is lowered by westerly winds, normally associated with a weaker water circulation. The opposite occurs in La Nina, as anomalous easterly winds pile up water towards the maritime continent, increasing sea level there. This issue is discussed in a chapter led by Janet Sprinthal in our recently published book on ENSO. Our recent research has shown that climate models project increased frequency of extreme ENSO and IoT events under greenhouse warming. Such projections have relied on utilizing models that are able to simulate such extreme events. Thanks to CIMIP, which is an initiative of the World Climate Research Programme, we are able to analyze output from several different climate models provided by several research institutions. The database now contains CIMIP 6 climate models which contribute to the 6 IPCC assessment report. The coordinated model output under CIMIP has facilitated model intercomparison. An example is a recent study by Planton et al., which provides a script in Python to compare key metrics related to ENSO. They found that CIMIP 6 outperforms CIMIP 5 in 8 out of 24 ENSO metrics, such as tropical Pacific climatology. For instance, the double intertropical convergence zone bias is reduced in CIMIP 6 compared to CIMIP 5. A better seasonal cycle, ENSO patterns, event diversity, and teleconnections. However, the coupling between the subsurface and surface temperature has degraded. There are actually many biases that still persist, such as the cold tongue bias. The so-called cold tongue bias is associated with a cooler than observed equatorial Pacific surface. Here showing analysis of CIMIP 5 models. The lower panel shows sea surface temperature variability evolves in different months, with a peak toward December when ENSO matures. This picture also shows how some models have completely wrong ENSO seasonality. The sources of such biases are complex and likely boils down to small-scale processes like the tropical instability waves and cloud physics, which are not fully resolved by global climate models. This plot now includes the CIMIP 6 models, ENSO on the right and IoT on the left. Note the large overlap in the intermodal spread between CIMIP 5 and CIMIP 6 in orange. Black lines indicate observations. Notice how the ENSO seasonality is quite reasonable. And the peak in the CIMIP 6 models is actually matches the observations better. But for the IoT, both CIMIP 6 and CIMIP 5 models are overly strong. In fact, this problem is slightly worse in CIMIP 6. ENSO modeling has a long history, and this is all covered in chapter 9 of the ENSO book, led by Eric Guiriardi. We recognized for a long time that in terms of future projection of ENSO sea surface temperature variability, such as the NINO 3 and NINO 4 indices, intermodal consensus is low. Some models show an increase in variability, some show a decrease, both in the Central and Eastern Pacific, as shown in panel C and D. But in terms of rainfall variability, the intermodal consensus is strong, and this high intermodal consensus stems from changes in the nonlinear processes governing ENSO. For instance, changes to an atmospheric dip convection, which is essentially a nonlinear process, occur under greenhouse warming associated with weakened water circulation. But changes in sea surface temperature are often masked by compensating changes in positive and negative feedback processes. Chapter 13 of the ENSO book covers this topic. Thus, our effort in understanding ENSO projections has moved into investigating the nonlinear processes that govern ENSO. Skewness is a measure of nonlinearity, which in the case of ENSO is also related to event diversity. In the Eastern Equatorial Pacific, or the Nino 3 region, where warm SST anomalies are stronger than cold anomalies, the skewness is positive. In contrast, in the Western Central Pacific, in the Nino 4 region, cold anomalies tend to be stronger than warm anomalies, thus the negative skewness. This nonlinearity stems from ENSO extremes. Extreme El Nino contributes to positive skewness in the Eastern Pacific, and extreme La Nina contributes to negative skewness in the Western Pacific. Thus, when we remove extreme El Nino and La Nina events, the skewness is reduced. The blue curve here in this panel compared to the black one. So this is related to spatial asymmetry. In CMIP 6 and CMIP 5 models, the Nino 3 skewness is weak compared to observations, while Nino 4 skewness is actually quite well represented, although slightly weaker. The spatial asymmetry can further understood through EOF analysis, decomposing the tropical Pacific SSTs into a conventional ENSO pattern in EOF1 and an east-west pattern in EOF2. The relationship between EOF1 and EOF2 is quadratic due to strong El Nino and La Nina at the extreme ends. If we add EOF2 on EOF1, we obtain an Eastern Pacific ENSO pattern. Subtracting EOF2 from EOF1, we get a Central Pacific ENSO pattern. Thus, extreme La Nina like 1988 and 1998 events is a Central Pacific ENSO, while extreme El Nino like 1982 and 97 is an Eastern Pacific type, governing that quadratic curve. The curvature can then inform the extent of this pattern asymmetry. If the curvature is weak, then Eastern Pacific and Central Pacific ENSO would be less distinctive. Indeed, in models, this curvature overall is weaker than observed. A parameter alpha is a measure of this curvature, which is generally lower in models. So for future projections, we would want to use only models that capture such curvature. In this study by Chai et al., we discarded models that simulate less than half of the observed curvature. What we get is then an increase in the variability of Eastern Pacific ENSO, stemming from increased frequency of strong events. The center of Eastern Pacific and Central Pacific ENSO differs from models to models. Thus, another reason why we didn't have an intermodal consensus in ENSO SST variability in the first place. So we can actually track these different centers using the EOF method. The increased variability turns out to be due to greenhouse force enhanced upper ocean stratification. Implementing similar approach for the Indian Ocean dipole, we obtain two principal modes. The first mode is conventional IOD, but the second mode shows variability primarily off Sumatra. This analysis separates strong from moderate positive IOD events. The strong positive IOD events like in 1994, 1997, 2006, 2019 all correspond with a positive AOF2, cooling off Sumatra. Moderate events in 1982, 87, and 2015 correspond with a negative EOF2, there would be a warming of Sumatra, which counters the cooling in EOF1. And thus, the moderate positive IoT events are signified by Western Indian Ocean warming. The index for strong and moderate events can be constructed using these EOFs, and the patterns are shown here. And we can see how these strong and moderate indices contribute to the double mode index, which is the conventional measure of IoT. Using models that better represent this curvature, we obtain a projection of reduced variability of moderate IoT, but an increased variability of strong IoT. These changes are due to mean state changes, such that the Ekman pumping that drives the moderate positive IoT warm anomalies in the west is weakened, while westward shift of convection is enhanced, leading to stronger cooling of Sumatra that signifies strong positive IoTs. It should be borne in mind that best models does not mean they are free from biases. They still exhibit overly strong IoT amplitude. In fact, in CMIP6 models, the skewness of IoT is severely reduced. Unlike in the ENSO case, the skewness is not so much related to pattern asymmetry between negative and positive events. This reduced skewness could be due to similar amplitude between positive and negative IoTs. Normally, positive IoTs tend to be stronger than negative IoTs, thus the positive skewness. This change should be investigated in a future study. One process behind the overly strong IoT amplitude is the thermocline depth across the equatorial Indian Ocean. Our recent study examines the issue and the implications for IoT future projections. In observations, the thermocline is pretty much flat. That is, the difference between thermocline depth in the west and east is around 0. But in nearly all models, the thermocline slope is positive, shallower in the east than west, as depicted in the lower left panel. A shallow thermocline tends to enhance SC coupling that promotes the growth of IoT, thus the overly strong IoT amplitude. The CMIP6 models seem to be worse than CMIP5 in this respect. Such ocean bias is also linked to biases in the atmosphere as well, such as rainfall with dry bias of Sumatra. So what is the implications on future projections? In this plot, we ordered the CMIP5 and CMIP6 models from least biased to most biased in terms of thermocline slope in blue. The red bars indicate future minus present thermocline slope. This shows that models with weaker bias exhibit a steeper thermocline tilt in the future. Models that in the present day already exhibit a strong thermocline tilt, they tend to exhibit smaller future change. Because the chromatological thermocline tilt matters for SST variability, there's a tendency for more biased models to project weaker SST variability than less biased models. This means, if we reduce such model bias, we would expect stronger IoT variability in the future projection, meaning the IoT projection based on current models is underestimated. To summarize, this plot presents ENSO and IoT amplitude plotted against each other for CMIP5 and CMIP6 models. Two things to note here is that models exhibit more severe bias in the IoT than ENSO. Secondly, there is an intermodal correlation between ENSO and IoT amplitude. This could mean that rectifying biases in one basin may impact the bias in the other. After all, the IoT and ENSO are linked via the Walker circulation, although the IoT is also generated by processes within the Indian Ocean. Changes in ENSO and IoT are expected to impact on other processes. Here is a study on Indonesian true flow that is currently under review. Using CMIP5 models, we clearly show that the future change in ENSO amplitude is tightly linked to the future change in the true flow amplitude. But this intermodal relationship is found in the subsurface around 100 to 300 meters. There is otherwise no relationship at the surface. There is also a link with the IoT amplitude change, but this could stem from the fact that ENSO and IoT are linked. What all this means is that a more reliable ENSO projection would lead to a more reliable projection of the Indonesian through flow variability. In summary, classical biases persist in CMIP6 models. For example, the Koltang bias, overly strong IoT, weak ENSO asymmetry. There are also emerging biases that require further investigation, such as the weak IoT skewness in CMIP6. So toward a more accurate future projection, it is necessary to select models, but bear in mind that the best models are still not free of biases. Secondly, consider event diversity. For example, EP and CP ENSO, strong moderate IoT. ENSO and IoT projections will impact on a host of climate processes. A more accurate projection of the climate modes would lead to more reliable projection in other processes such as the Indonesian through flow. So the current study of future projections point to increased ENSO and IoT variability. We have a paper coming up on ENSO projections that will appear in Nature Reviews Earth and Environment Journal. So with that, thank you very much.
Okay, thank you very much, and give applause to Dr. Agus Santoso for his very nice presentation. I invited all participants to raise questions. You may raise your hand so you can ask a question directly, or otherwise you can just type your question in the chat room and we will write your question and ask it to the presenters. Please, if any question from room? I don't see any question. Okay, there is a question from Mbak Lamona Bernawis. Thank you very much for the interesting talk, Pak Agus. Would you have an idea why the model for IoT has more bias than ENSO? Please, Pak Agus, you may answer the question directly.
Thank you very much for the question, Mbak Lamona. Yeah, actually, very good question. Yeah, I think why it has more bias is because, well, you can put it this way: why there is less bias in the ENSO? It's because I think people have been paying attention more on ENSO than IoT. So when they do modeling, they try to fix the ENSO first. But after all, it's all interlinked. And probably because of the size of the basin, Indian Ocean is small, so any bias that occurs there will be probably amplified. That's all I can say for now. Yeah.
Okay, thank you. Other question, please. Otherwise, I have a question for Pak Agus.
Silakan.
Yeah. It is actually the classical debate that between ENSO and IoT is something that researchers used to discuss whether it is dependent or independent between the two. My question is that how in CMIP 5 or CMIP 6 also represent this dependent-independent issue in the models. Do you have any clue for that?
It's very good. Actually, in current models, the IoT is more weakly related to ENSO. If you look at observations and you do correlation between DMI and INO 3.4, the correlation is quite high. It's like 0.7. But in model, it's actually quite low. And there are some models which have IoT but not related to ENSO at all. So I would say because of this, it is fair to say that the IoT is also generated within the Indian Ocean, not because of just a response to ENSO.
Sorry. Yeah, well, no, my question is not that really stable, but I can get your clue. Thank you very much for that. One more question maybe from the floor. I don't see any question there, but maybe the last question from me, Pak Agus. Uh, I don't know if the running model for CMIP6 is also similar with the CMIP5. That is from for the future projection from 2005 till to 2100. Is it the same or not? But my question is that if so, then we already have from 2006 to 2020 then. How well this time span has been represented in the model CMIP6. I mean, did the 2019 IOD event, that is the strongest in the history so far, if I'm not wrong. So how well represented in the model for the IOD?
So if you're talking about CMIP models, the model does not capture, the 2019 event by itself because it's a freely running model, right? The model is run freely, so it's not trying to capture the 2019 specifically. It could, it just presentation. It looks like the IOD in CMIP6 is actually worse than CMIP5.
Okay. Yeah. I got that. And what is the do you have any clue why it is CMIP6 it is worse than the CMIP5?
That's not clear. We think we need to do more research.
Okay. Yeah. Okay. Thank you very much, Pak Agus, for very nice talk. Yeah. And we move to the next presenter. We have okay, let me check. We have AR Kurnia. Okay, let me check. Yeah, we have AR Khairunisa. I hope that she already here in the room. Nisa,
yes.
Are you there? Okay. Please, time is yours. Maybe the technical unit can present her presentation.
Greeting for all participants in this conference. Let me introduce myself. My name is Air Hairunisa, graduate student on Earth Science program from ITB, Indonesia. In this time, I will present the result of our research about the oceanographic condition during the negative IOD event 2010 around Indonesian seas. As we know, there is a phenomenon caused by air-sea interaction in the Indian Ocean called as Indian Ocean Dipole or IOD. This phenomenon characterized by temperature anomaly between western and eastern region. The temperature anomaly that occurs during the IOD event will affect changes in other parameters such as the depth of thermocline, sea surface height anomaly, and ocean heat content. Indonesian region, which is in this case is West Sumatra and South Java Seas, are part of eastern region of Indian Ocean, which is the temperature variation in this region play an important role in the formation of IOD event. Previous studies showed that positive IOD will cause negative height anomaly in the eastern region, while the negative IOD event will cause positive height anomaly. Furthermore, the positive IOD also cause decreased OHC value in West Sumatra Seas, and also known that ocean heat content variability is primarily driven by thermocline depth variation. Based on that, Aim of this study is to examine oceanographic conditions during negative IOD event 2010 in West Sumatra and South Java Seas, with the oceanographic condition in question are an anomaly of sea surface height, surface wind, and ocean heat content. Okay, Figure 1 shows the research area, and the table shows the description of data that used in this research. In this research, sea temperature data from surface to 300 meters depth and sea surface height are obtained from Hybrid Coordinate Ocean Model or HICOM. Horizontal and meridional wind velocity are retrieved from ECMWF. Also use Dipole Mode Index and Nino Index from Jamstack to supporting analysis. Meanwhile, for ocean heat content data are calculated using equation as below. To assess and analyzing, two transects are made and also chosen 3 points each transect, and two transect is shown by dashed green line. AB transect is represented for West Sumatra Seas, while BC transect is to represent South Java Seas. Next to the results and discussion section. First, here is a spatial plot of monthly SSTA in 2010. We can see that there is positive SSTA occurs since the beginning of the year. From this, we can notice that there are decreasing of SSTA value during June and July. And it is start to increasing on August, coincide with onset of negative IOD event. We can notice that there is a highest positive SSTA value within the coastal area, and its values are decreasing towards the offshore. The strong positive SSTA are happen during the negative IOD event from August, September until October. The significant decreasing is happen in November, or 1 month after the end of the IOD event. To see the vertical temperature anomaly condition in the research study, the Hofmuller diagram are made. Figure 3 is for each point in AB transect, and figure 4 is for each transect in BC transect. We can see that positive temperature anomaly first appeared in the subsurface layer in April. We can see in here. There are an increasing value of temperature anomaly in subsurface layer in both transects during the IOD event. And similar to the surface, temperature anomaly decreases gradually in the subsurface layer since November, or 1 month after IOD event ended. We can see that positive anomaly still can be seen at the end of the year. It's expected as influence from the La Nina phase that happened in Pacific Ocean. As previously mentioned, the change in temperature anomaly will cause change in ocean heat content. This figure shows the spatial plot of monthly ocean heat content in 2010. From this figure, we can see that the high value of ocean heat content has been found in the period of February until April. And since May, we can see that the heat content are decreasing, especially in the offshore area. While in the area around the coast of West Sumatra and South Java Seas are relatively has a constant value until the end of negative IOD. And 1 month after the end of the negative IOD, in November, we can see there is a significant decreasing of heat content in all area. To see the temporary changes of ocean heat content in each transect, it is a Hofmuller diagram of ocean heat content for each transect. From this figure, we can see that there are a decreasing value of heat content since May in both transect. And the decreasing of value continued in the BC transect until the end of the IOD event. Meanwhile, in the AB transect, the value of ocean heat content R tends to be constant until the end of the negative IOD event. We can see there is an increasing of value of ocean heat content both in transect during the IOD event. Although the value are increasing are not significant. An increasing in ocean heat content value still occurs on the BC transect, even though the IOD event has ended. It's expected are influenced from La Nina phase in Pacific Ocean. To see the vertical condition of ocean heat content, we also made a Hofmuller diagram of ocean heat content from surface to 300 meters depth for each point. The thick black line is the isotherm 20, or we call ST20, and this line is assumed as the thermocline depth. We can see here that T20 line depths are following the change in the ocean heat content value, which the variation of depth T20 are getting shallower when the OHC is decreasing, and it getting deeper when the heat content is increasing. We also notice that there is a wider space between the isotherm during the negative IOD event in August, September, and October. This is caused by warm water during negative IOD event, with dominantly the seas, so the isotherm line are get wider. It is also indicate the thicker mixed layer depth. The next parameter is the surface height and surface wind, which is shown in figure 9. From this figure, we can see that positive surface height anomaly values began to appear in April, which is it coincides with the temperature anomaly first appear in subsurface layer. The positive sea surface height anomaly are gradually expanding in May, and there are also increasing value until the negative IOD event on August, September, and October. But the positive sea surface height anomaly still dominate in November. For the surface wind, we can see there is a weakening of wind surface since in July, and there is no significant change during the IOD event. When the IOD event are ended in October, the wind are become to change its direction back to the west. The positive sea surface height anomaly that still occurs in November and December are expected as the is caused by the positive temperature anomaly that still occurs in the subsurface layer, which are influenced from the La Nina phase. The next figure is Hofmuller diagram of sea surface height anomaly in West Sumatra or AB transect and South Java or BC transect. We can confirm from this figure that the positive sea surface height anomaly are first occur in April in West Sumatra Seas. In this figure also we can see there is a propagation of sea surface height anomaly to the east, especially in BC transect. This propagation is expected association with propagation of Kelvin wave, but to confirm this we need further research. From all the results we obtain in this research, we can conclude several things. That in the negative IOD event 2010, the temperature anomaly first occurred in the subsurface Greeting for all participants in this conference. Let me introduce myself. My name is Air. In this, we need further research. From all the results we obtain in this research, we can conclude several things. That in the negative IOD event 2010, the temperature anomaly first occurred in the subsurface layer several months before the onset of IOD event. Second, the forming of positive temperature anomaly in the subsurface layer is followed by positive sea surface height anomaly in the same time. The third, the increasing of ocean heat content is a response from the developing of positive temperature anomaly. The fourth, temperature anomaly and increasing ocean heat content also followed by deepening of thermocline, or in this research called as T20, and thickening of mixed layer depth. Finally, that's all from me. Thank you for your attention.
Khairunisa, maybe audience can give their applause through reactions, and please you may choose the emoticon you like. And there is already one question from Aulia Dian Johanlis from ITB to Nisa. Thank you for your presentation. I want to ask one question. Why you choose 2010 as your research time? Is there a reason for it? Thank you. Maybe please address that question, Nisa.
Okay, can you hear my voice?
Yeah.
Thank you for the time. Okay, for the first question, why I choose these years, because the first reason is the data availability. In this research, I use HiCom model, where is the data only available until 2015. And the second one, I want to know the condition in negative IOD. We know that negative IOD is more rare happen than positive IOD, so that's interesting for me. Thank you.
Thank you very much, Nisa, for the question. I hope that addressed the question from Aulia Dian. And due to the limited time, I think we need to go towards the next session, next presentation. That is the presentation from Adelina Lumban Gaul, who will discuss linkage between active and weakening MGO event to seasonal variation over maritime continent. The Adelina Lumban Gaul is from ITB, Department of Earth Science, Faculty of Earth Science and Technology. Adelina, are you already there?
Yeah.
Okay. Yeah, maybe the technical support can start her presentation.
Good afternoon, everyone. My name is Adelina Lumban Gaul from Faculty of Earth Science and Technology in Bandung Institute of Technology. For this mini symposiums, I want to present the linkage between active and weakening MGO events to seasonal variation over maritime continent.
So we flashback again about one of the planetary scale phenomena, so-called as MGO. Madden-Julian oscillation, or MGO, is an interseasonal phenomenon which has period 30 to 60 days and influences the tropical region, especially in the maritime continent. MGO can be detected by using RMM index and by the AOF, or empirical orthogonal function method. RMM paces has 8 paces for detect MGO, which MGO affects the maritime continent area in paces 3, 4, and 5, with pace 3 is in the western part of Sumatra Island. And what is the effect of the MGO? Biolinic 2002 tells that the MGO can affect upper level wind and sea level pressure, disturbance in tropical cloudiness, rainfall, and also affect the frequency extreme weather events such as flood in winter and tropical cyclone and monsoon in summer. So I will tell you about the process of the MGO. The MGO is known as a zonal wind oscillation cell that propagates eastward with an average speed of 5 meters per second along the equator from Indian Ocean to Pacific Ocean. And there is active and suppressed envelopes. The active envelope indicates by above normal thunderstorm activity from the result of the strong upward vertical motion, and this region of enhanced convective activity results in above normal precipitation and wind speed. In contrast, suppressed envelope indicates below normal precipitation and cloud cover due to MGO-induced sinking motion or subsidence. So, we characterize the ocean atmospheric parameters by the active and weakening MGO intraseasonal phenomena in rainfall propagation and SST based on their effect on maritime continent. We do this research based on the active MGO shown by the convective signal propagates eastward through the MC and reach the Western Pacific Ocean in propagating event, and the weakening MGO shown by the convective envelope decouple from zonal wind anomalies and weaken over the MC, not reaching the Western Pacific Ocean in a propagating event. We also divided by two main monsoon regimes are selected, which is the northern monsoon from November to March and southwest monsoon from May to September. Our study area covers latitude 12 north to 12 south and longitude 90 to 150 east, which is part of the MGO oscillation area over maritime continent. In understanding the characteristic of the MGO, we use the OLR data for detecting cloud cover, zonal wind in 850 millibar, RMM index to classify the active and weakening MGO, and also precipitation rate by using TRMM and SST anomaly to analyze the effect of the ocean atmosphere. Firstly, we use bandpass filter with the frequency cutoff 20 to 100 days, and then we classify two types of MGO, active and weakening, based on the RMM index. To be classified as active MGO events, the MGO must propagate from phase 3 to phase 5 with an RMM index amplitude greater than 1.0 and exhibit a counterclockwise progression in each phase area, especially in phase 4 and 5. The MGO weakening event is defined as an MGO propagation event that crosses the phase 3 to 4 area with an RMM index amplitude greater than 1.0, similar to active, but weakens and exceeds phase 5 with RMM index less than 1.0. After that, we composite the data, both active and weakening MGO, and make the spatial plot. So from 2010 to 2019, 48 MGO events were identified over the maritime continent. And MGO occurs more frequently during boreal winter season, which is 24 cases, than the boreal summer monsoon, which is 20 cases. And the highest number of days, which is greater than 40 days, highest active MGO is terminated in December, September, March, and June, while the weakening MGO, the highest occurrence only in the September. And from this graph, it can be shown that the active MGO more frequently occur during boreal winter monsoon. And we also identify the MGO using zonal wind 850 millibar, and also show the OLR propagates to the east at the speed of 4 meters per second. And negative OLR is very intensive in the boreal winter in pace of active MGO, especially in the eastern part of Indian Ocean region and South Equator. In contrast, the weakening MGO shows the uneven distribution of OLR anomalies and weak convection. The next figure shows composite anomalies of OLR for the lag day, the day of the MGO, and the lead day. And from the lag day, we can show that active MGO show a stronger and more pronounced negative anomaly than the weakening MGO. And then for the day of the MGO, there is an active MGO shows a negative OLR covering the maritime continent with stronger intensity. And for the lead day, it can be shown that there is a strong negative anomaly still occurs in an active MGO, while weakening MgO has experienced less convective. And this also indicates that the intensity of the convection strength in the Indian Ocean when the MgO is formed will determine the formation of an active and weak MgO. Strong convection characterized by lag day, which is negative Euler anomaly, contribute to form an active MgO. Conversely, a weak negative Euler anomaly at the lag day in the Indian Ocean would form a weakening MgO. So the next slide shows the MgO frequency in boreal winter and boreal summer monsoon. We give you the detail of active and weakening MgO based on two regime monsoons like the lag day, day of MgO, and lead day of MgO. The lag days show weakening MgO events were more dominated by negative SST anomalies than the active phase of MgO, which has positive SST anomalies in the eastern Indian Ocean. The positive SST anomalies dominate the maritime continent region, with the highest intensity of positive SST anomalies occurring in the 115 to 150 east region, with SST anomalies greater than 0.3. And in the lead day, there is a decreasing intensity of the SST anomaly compared to the day of MgO. The weakening of the MgO is strongly dominated by negative SST anomalies, which are quite strong compared to when the MgO is active, especially in the southern hemisphere. The next figures show the MgO influence the maritime continent detecting by the precipitation rate. The boreal winter and boreal summer monsoon significantly affect maritime continent. This is also detected by this figure in the boreal summer monsoon, which has a smaller rainfall intensity than the boreal winter monsoon. In boreal winter, rainfall more than 20 mm per day spread over the maritime continent, with dominant occurs in the Indian Ocean, northern and southern Java Seas, and Karimata Strait. The fairly high intensity of rainfall generally occur during the active phase of MgO events compared to the weakening MgO. And in the boreal summer, intense rainfall occurs to the north of equator, with dominant rainfall clusters on Papua Island and Pacific Ocean. This is an interesting phenomenon, and other regions that do not experience high rainfall during the boreal summer monsoon. This is due to the movement pattern of the Australian cold monsoon winds from the southwest Pacific and Arafura Sea. And the intensification north of the equator during boreal summer monsoon also occur during the weakening phase of the MgO. And from this discussion, we can conclude that from the 48 total MgO events during 2010 to 2019, the highest MgO events occurred during the active MgO phase, as many as 30 cases, with the most MgO cases occurring during the boreal winter season was 24 cases. During the boreal summer monsoon, weaker intensity parameter occurring in the weakening MgO phase than active MgO. Negative Euler anomalies and rain rates will increase in intensity in the northern part of the equator. The positive SST anomalies generally be centered at 115 to 150 east, also applies to the winter season. And during winter monsoon, negative OLR anomalies and rain rates indicate that highest intensity is more dominant in the south of equator than the Indian Ocean when the MgO is active. And the analysis results show a fairly close relationship between parameter variation based on the characterization of the MgO against seasonal variation. So this is my presentation. Thank you for your attention. Good afternoon.
Thank you very much. Give applause to Adelina for that very nice presentation about the MgO. I invited all audience to raise the question to presenter. So far, I don't see any question in the chat room. So maybe my question to Adelina, is it compatible between the weakening of the MgO with the dry phase of the MgO? We know that the MgO has the wet phase, that is the active MgO, and the opposite one is the dry phase. how we define the weakening MGO related to the dry phase. Is it similar or is it something else?
Thank you for the question. Pardon me. Would you mind to tell it again because I didn't hear it clearly, sir?
The difference between the dry phase of MGO with the weakening of MGO, is that similar or something else?
Oh, the weakening, we can find from the presentation that the weakening MGO, which is the convective envelope that the couple from zonal wind anomalies and weak over the MC. So it is not crossing the it is not crossing the maritime continent or didn't reach the Pacific Ocean. But the dry MGO maybe is the meaning of like a condition which there is a passive pace of MGO, which is from the OLR the RMM diagram. We could see that there is a the RMM is less than 1.0. So yeah, the weakening is really specific for the propagation for the unpropagate through the MC and less than 1.0 in the past 5. But the dry MGO is not specific like weakening, which is I tell it here.
Okay, so the weakening MGO is not propagated MGO through maritime continent or through Pacific Ocean. I see Pak Yuda Jamil raise his hand. Please, Pak Yuda. But I think we can make it short.
Yeah, thank you. Can you hear my voice?
Yeah.
Yeah.
Okay, just a quick question. You choose the month in terms of 5 months, right? Not 3 months. I just wonder why. Thank you.
Oh yeah. Thank you. So I partitioned this into 2 monsoon season based on the curves et al. In 2012. So that the research, this research showed that the MGO is really controlled by the ITCZ phenomenon. And actually, I use this, I make this research with 4 seasons, which is in the transition to transition space, and then winter and summer monsoon. But actually, I couldn't find the pattern to show that there is a difference between active and weakening, and also what is the difference between the summer boreal and the transition pace, like that.
Okay, one short question. Maybe you can address it also very shortly. How are the SST respond during the weakening and active MGO event? The question from Ahmad Duha.
Okay. So from the slide that we have seen before, active and weakening based on the winter and summer monsoon. And MGO is related to the SST could be detected and really can be detected by the active MGO. And maybe I can show you, or I hope you remember from the day lag, winter season get more warm SST in the western part of Sumatra Island and over MC compared to the summer monsoon. And Weller and Hampton in 2004 find out that the increasing of MGO intensity in the ocean occurs along with the increase of evaporation due to the positive SST anomalies before MGO occurs. And it means that the warm SST before MGO propagation is really contribute to the highly MGO intensity. And active MGO show in the boreal winter, there is a highly warm SST compared with the summer. But for the weakening, especially in summer monsoon, we could see that there is a high intensity of negative anomaly SST, which is a cool SST. And as the warm SST as the contributor of the highly intensity of MGO, which is an active MGO, so the cool SST cause the MGO pass in the MC
classified as the weakening type of NGO, like that.
Okay. Okay, due to the limited time, I think we stop the discussion. So it's really interesting discussion actually, but we need to move forward to the next speakers. So we have Genia Versa Fernanda, who will present a schematic model of low temperature and high salinity seawaters in southern Java of Indian Ocean during ENSO and IOD 2017. Genia, are you ready?
Yeah. Hello?
Is Genia here?
Yeah.
Yeah, okay. Please, maybe technical support can play the presentation.
Good afternoon, honorable audiences. Thank you for being here. My name is Genia Versa Fernanda, and I'm so honored to be here. In this occasion, I would like to present my research under a title, A Schematic Model of Low Temperature and High Salinity Seawaters in Southern Java of Indian Ocean during ENSO and IOD in 2017, which I will divide as 5 main parts. So without any further ado, let's move to the first part. As we all can see that Indonesian waters are influenced by changing wind system that we usually call as monsoon. Furthermore, in southern Java, that is offshore and directly connected with the Indian Ocean, where upwelling might occur in its season from June until August and mid-October actually. But it's not only influenced by monsoon, it can also be affected by ENSO and then IOD and also Indonesian coast flow. Upwelling itself usually identified with the lower temperature and higher salinity in the upwelling area. So in this study, we use the two index for low temperature and high salinity to know the probable upwelling propagation with schematic model. So the method here, we get the temperature and salinity data from HICAM in 33 depth layers in 12 months in 2017. And then we process in MATLAB to get the horizontal spatial distribution of each layer depth. And then we observe the movement of low temperature and high salinity. For the low temperature is not more than 26 degrees Celsius, and the salinity, the minimum is 34 PSU. And then we observe the horizontal spatial distribution to get the schematic model of temperature and salinity. The second data we use is wind data from ECMWF to get the directional spread pattern and surface wind speed. We can process the wind data in ArcGIS to create the wind map actually. And also the ENSO and IOD data, we divide it as two for the ENSO with SOI and also ONI index, and for the IOD we use triple mode index, and we can make a correlation between the temperature and salinity data that we kept previously with ENSO and IOD. So the first result is wind map in each season during June, July, and August in 2017. As we all can see here that the wind moves from southeast to the northwest. It happened because the pressure in Asia continent is lower than the Australia continent. It happened because in the Asia, we get a lot more exposure of sunlight, so the pressure is much lower than the Australia counterparts. So the wind moves from Australia to Asia, so it moves from southeast to the northwest. As we all can see here that the June has wind speed of about 8 meters per second in the offshore area, and in the coastal is about 4 until 7 meters per second. And in July, the maximum wind speed range from 7 to 9 meter per second in some location and 7 until 8 meter per second in others location. And in August, actually, it almost has the same wind speed from about 7 until 9 meter per second, but the spread is actually more diffuse and not fixed on the coastal or the offshore area. And for the second is April average temperature we get from HICOM for the temperature data. We use 6-layer depth in here, and also the August average temperature, as we can see that in the surface or in the 0 meter. The temperature in April is actually higher than the temperature in August, and it happened because of because August is season. So the wind speed actually is stronger if compared to the wind speed in April. And also we can see that the April average salinity here and the August average salinity, we can also see that the August salinity in the surface or in 50 meters is higher than if compared to April average salinity in 0 meters or even in 50 meters. From this data, we can get a schematic model, and the first is schematic model of temperature and salinity with the depth of 50 meters. We can see for the temperature here, in the coastal area, it has lower temperature for 24.5 until 26, and then 23 to 24.5 degrees Celsius in coastal area, and in the offshore area it actually has higher temperature. And as for salinity, we can also see that the salinity here is more diffuse if compared to the temperature result. And actually, the upwelling occur in the coastal area during the east season until the transitional season 2, causing a mixing process in the inner layer, subsequently raising the cold temperature to fill the void in the surface. So the surface will has a lower temperature rather than the area that the upwelling did not occur. And for the next is actually the schematic model of temperature and salinity with depth 75 meter. And it's actually almost the same with the previous depth, with the lower in the coastal area, it has lower temperature if compared to the offshore area. It's because it happens because there might be upwelling happened in the coastal area here. And for the salinity here, actually in the coastal area here has higher salinity value if compared to the West Java here. So it might be happen upwelling here because it has high salinity and lower temperature in this area. And then the last is correlation between temperature and also IOD. And for the correlation between temperature and ONI index, it's actually when the temperature is decreasing, the ONI index is actually also decreasing. So I think it has linear correlation during the east season. Meanwhile, for the IOD, we can see here that the DMI is actually the lower temperature happened during IOD positive phase. in almost all months actually, except the December in 2016. And for the correlation between salinity and ENSO and IOD, we can see here that for the IOD first, from May until September, actually the salinity value is increasing significantly, but for the IOD is actually from July until October is decreasing. And for the correlation between salinity and soy, actually during May until October, then again, the salinity is increasing because it's the same data here, the salinity. But the soy is not constant, it's increasing and then decreasing and then constantly increasing again. And for the correlation between salinity with anomaly SLC in 3.4, it actually also has negative correlation. So for the conclusion here, the high upwelling based on the minimum temperature of 26 degrees Celsius and the maximum salinity of 34 should starting to occur from the depth layer of 150 to 125 meters, rising to a depth layer of 75 until 50 meters, the high upwelling ones. It also occurring at latitudes 108 until 109 degree, and then in other location. For the high upwelling occur from July to October when southeast monsoon winds at a speed 8 meter per second until 9 meter per second, I think, for July and August, resulting in dominant upwelling growth moving from the east to the west. The expansion of the upwelling itself tends to be affected by iod positive phase. And this research actually has been acknowledged by Marine and Coastal Data Laboratory, Marine Research Center, Research and Human Research Agency of Ministry of Marine Affairs and Fisheries. And that's all for my presentation. Thank you for your attention and good afternoon.
Thank you very much, Genia, for presentation. Give applause to Genia. You can give the reaction in the reaction icon there. I see question in the chat room of mechanism or phenomena which control eastward warm water at 50 to 75 meter depth. Please, maybe you can address that question, Genia.
Thank you, sir. I would like to answer the question. Actually, for the phenomena...
Your voice is so low.
Oh, I'm sorry. Thank you for the question. Is my voice already clear?
Yeah. Please, go on.
Thank you for the question. I would like to answer the first question. For the mechanism or phenomena which control eastward warm water at 50 until 25 meter depth is actually can be influenced by wind and then Lewin current from Australia continent because it moves from Australia to Indian Ocean, I think. But it needs more research to know the actual reason.
Okay, I hope that answered the question from Raden Bagas. Now the question from Ahmad. I don't really clear the name, but the question in bahasa Indonesia, penelitian HICOM di tahun 2017 tersebut, apakah dapat menjelaskan secara signifikan untuk kondisi saat ini? Mungkin pada tahun 2017 kondisi ENSO dan IOD ketiga itu apakah bisa menjelaskan kondisi saat ini? That's the question. Genia, please address that question.
Okay, thank you. Does it mean the correlation between sea surface temperature in 2017 with ENSO and IOD in 2017 or in 2021?
I don't really know the question from the audience. Otherwise, we can move forward to the question from Pak Agus Santoso. Dr. Agus Santoso, thank you very much for the presentation. I wonder how much the influence from previous year condition via Rossby wave, which evolves into Kelvin wave along equator towards Sumatra. Can you address this question, Kenya?
Okay, thank you, Dr. Agus, for the question. Actually, for the influence from previous year condition via Rossby wave, it needs more research because I don't centrally in Rossby wave or Kelvin wave along equator towards Sumatra. So I think it's interesting to look deeper to future research, Mr. Agus.
Okay, I hope that can answer those Dr. Agus questions. I think we need to move forward to the next speakers because time goes very fast. Now we have Ahmad Duha Habibullah. He will present his research about sea surface temperature variability in Indonesia and its relation to the two regional climate indices. Ahmad Duha Habibullah, are you ready?
Yeah, I'm ready. Can you hear me? I've already sent the video. Yeah, absolutely.
Okay. So the presentation will live or the video?
No, I've sent the video in advance.
Okay. Yeah, please, the technical support can play the video.
Hello and welcome. In this presentation, I would like to share our research, sea surface temperature variability in Indonesia and its relation to regional climate indices. Let's get started. Sea surface temperature, or SST, plays an important role in the physical processes that occur in the sea. SST is an effective tool to analyze various phenomena and their spatiotemporal variabilities. Some robust examples of the use of SST have been demonstrated, from estimating the fish distribution, revealing tidal mixing signature, until defining marine heat waves event. SST can affect processes in the atmosphere such as air temperature, relative humidity, and wind speed. Investigating this spatiotemporal variability in Indonesia is interesting since Indonesia is located between two oceans and two continents, causing various atmospheric and oceanic dynamics. There are some climate indices defined in the Indonesian seas or around Indonesian seas, such as the Dipole Mode Index, the Australia Monsoon Index, and also ENSO indices such as Nino 3.4 and Nino 3 are defined around the Indonesian seas. So the spatiotemporal variability analysis in correlation to these indices is necessary to reveal how much the contribution of each index. This research aims to investigate the spatiotemporal variability of SST in the Indonesian seas. Global modes of SST variability have been investigated. The time frequency analysis is also efficient to map the distribution of the tidal harmonics and their spatial distribution based on the SST data. Combining these approaches, we focus on the dominant modes in the Indonesian seas and concurrently extend the harmonic analysis to another periodicity. The dataset that we use is the ERA 5 monthly average data on single levels. The spatial resolution is 0.25 degree by 0.25 degree, and the monthly temporal resolution from January 1979 until March 2021. However, The data needs to be retended to eliminate the global warming signal. The domain of this research is from 16 degrees south to 16 degrees north and 90 degrees east to 150 degrees east. And these are the climate indices that we use in this research. The empirical orthogonal function analysis is a technique to study the spatial variability of data and how it changes with time. The EOF calculation is done by using the EOF function in the climate data toolbox for MATLAB. The time frequency analysis is performed by a regular transforming function, but the transformation is then repeated to every station in the domain grid as shown here. The output of this process is a three-dimensional matrix, where the third axis is represented by frequency or XF. The spatial analysis is performed by slicing the output at a specific frequency that has the dominant peaks. The spectral peak distribution will be cross-correlated to the climate indices to identify the possible atmospheric phenomena. The time frequency analysis is performed using the MATLAB p-spectrum function from the signal analyzer toolbox. We also use the Pearson correlation coefficient to find the correlation between the principal components of SST variability and the climate indices with the formulation given by this formula. And then the calculation is iterated in every station using the X-score theory function in the climate data toolbox for MATLAB. So with that being said, these are the results. Since the long-term trend has been removed, the main variabilities from the EOF now only contains the short-term variability and can now be described by transforming them into a frequency domain plot. This is the PSD of the first 6 principal components. The principal components 1 shows that the most influential mode is the annual oscillation by 60.9%, followed by the annual and semi-annual oscillation periodicity and the principal component number 2 by 19.0%, and principal component number 3 by 7.8%. The principal component number 4 is dominated by the semi-annual oscillation by 2.9%. Meanwhile, the 5th and 6th components are not showing sharp peaks as the previous principal components. Instead, they are distributed interannually from 0.5 to about 11 years periodicity. The rest principal components are not shown since they are considered to be insignificant according to their percentage. This is the PSD plot of the climate indices. The Australia Monsoon Index shows a clear signature of the annual and semi-annual periodicity. It is matched to the sum of the 4 first principal components, although the magnitude is different. It is likely due to the differences in the medium among these values, that is SST and zonal wind. In contrast, the power spectrum distribution of Nino 3.4 index and dipole mode index does not have sharp peaks, so superimposing PSD plots of these does not give any significant similarities. However, some peaks of the 5th principal components are similar to the MI in a time series plot. Thus, the Nino 3.4 index effect on the variability of SST in Indonesia is suggested to be insignificant and will not be more investigated. Now let's talk about the EOF maps. The first mode contributes more than triple variability than any other mode, or 60.9%. It shows the annual cycle with an opposite sign, dividing Indonesia's northern and southern regions, meaning that the SST in Indonesian waters reaches their maximum in the boreal winter and reaches their minimum in the boreal summer. This yearly variation is weaker around the equatorial region. This pattern presumably results from the variation of seasonal solar radiation intensity. According to its corresponding principal component, it is highly correlated with the AUSME with the index of correlation of 0.769. The second mode is the strongest in the South China Sea. Almost no antiphase anomalies are found around the Indonesian region. The second mode is dominated by annual and semi-annual oscillation. Mode 2 is most strongly correlated to the AUSME, with the correlation index R equals 0.407. As in Mode 2, Mode 3 is also dominated by annual and semi-annual oscillation. There is a sharp barrier between the east and west region of Indonesia. Mode 3 is weakly correlated to the AUSME with the R equals 0.013. This correlation value is not as intense as the previous modes, but as the PSD result suggested, the periodicity is matched to the AUSME index. Mode 4 is dominated by semi-annual oscillation. The strongest variability is from the northern part of Australia next to the Timor and Arafura Sea to the South China Sea, crossing the Java Sea diagonally in the middle. The half-year periodicity is strongly found in the Indonesian seas. The correlation value to the AUSME is also there. The strong antiphase pattern of the west coast of Sumatra is most strongly correlated to DMI with the R equals minus 0.342. Mode 5 is most strongly correlated to the DMI with the R equals 0.311. The spatial pattern suggests that it is matched to the definition of the dipole mode index, where the peak variabilities are the strongest on the west coast of Sumatra. Lastly, we do not find any reliable explanation for mode 6 as it is not correlated to any of the climate indices we utilize in this research. In the EOF analysis, we have discussed 4 first modes that are correlated to the AUSME. The PSD plots of its corresponding principal components are also strongly correlated to the AUSME. Now we want to analyze further the spatial distribution by applying the spatial power spectral density. Now from this figure, we can see that almost all of the entire domain is affected by the annual oscillation phenomena. The most intense annual variations are located in 2 clusters. The first cluster is located in the Indian Ocean, especially on the southern coast of Java, the Timor Sea, the Arafura Sea, and at the Banda Sea. It is also found in the South China Sea, including the Karimata Strait and the Philippines Islands, extended to the Pacific Ocean in the east. However, this variation is a bit weak in some areas. The annual oscillation signature in the equatorial Western Pacific, the Celebes Sea, and the Makassar Strait and around the Sunda Strait is not as pronounced as in the other areas. In the Celebes Sea, they form a shadow-like feature as if it's being shined from the northwest side of the Mindanao Island in the Philippines. In the second place, the semi-annual oscillation is also formed a unique signature. The signature is extended from the southeast part of the domain, such as the Timor Sea and the Arafura Sea, to the South China Sea and the Andaman Sea in the northeast area. Some areas between these seas are also affected by semi-annual oscillation signatures, such as the Java Sea, Banda Sea, and the Flores Sea. The other area, such as the western coast of Sumatra Island and at the Pacific Ocean, is not affected by the semi-annual oscillation, or in other words, the effect is too small. This is the comparison plot between 2 points, where the power spectrum peaks are different. On the left side, it is the power spectrum of the Indian Ocean, where the annual power spectrum peak is high, but there is no significant semi-annual peak. In contrast, the power spectrum in the Java Sea is dominated by the semi-annual peak, while the annual peak is also present, but less pronounced. In conclusion, the variability of SST in Indonesia primarily consists of 2 harmonics, the annual and semi-annual oscillation. According to the EOF analysis, the variance of SST in Indonesia is strongly correlated to the seasonal cycle. The annual and semi-annual oscillation can be separated using the frequency separation technique. And especially in the western coast of Sumatra, there is a strong correlation to the Indian Ocean dipole phenomena. It is vital to find more evidence regarding the semi-annual oscillation and the underlying phenomena that are responsible for forming this pattern. It is also recommended to overlay the SST data with some other spatiotemporal data to investigate the relation of the spatial pattern at various periodicities that is not yet described in this research. Thank you for your kind attention. Let me know if you have any questions and feedback regarding my presentation.
Thank you very much, Ahmad Duha, for a very nice presentation. Please give applause for the presenter. And we know the question. Very nice presentation. That is the comments from Lamona Bernabes. Would you suggest why the northern part of Papua or West Pacific is not really holding the annual or semi-annual oscillation? Please, Ahmad Tuhar, can you have answer for that?
Okay. Can you hear me?
Yeah.
Okay, brilliant. So the annual and semi-annual oscillation is actually containing the same phenomena, that is the Australian monsoon index. So the Australian monsoon index, we classically knows that the Australian monsoon index is only containing the annual periodicity. So thus we have the annual or seasonal cycle between boreal summer and boreal winter, or or the opposite. So our aim is that we have to separate the annual and semi-annual oscillation. So we've seen that the annual and semi-annual oscillation is separate. Regarding the question, the Western Pacific, in the northern part of Papua, is not really holding the annual or semi-annual oscillation. Is because that the location of the northern part of Papua is in the equatorial area. So the seasonal or annual cycle is low because the latitude is also low. But in the semi-annual oscillation, um, there is a not strong variability as well, because uh, the, the path of the Australian monsoon is crossing the Java Sea from the east north from the southeast in the north part of Australia to the Asia continent. So it is obvious that the northern part of Papua is not holding the annual or semi-annual oscillation. So
Okay, next question. I hope that answered the question from Lamona Bervis. Otherwise, you can add your comment to the private message or to the chat room. With next question from Nabila Afifa. Thank you, Habib, for the nice presentation. I would like to ask, why is there a spatial time frequency transformation along with the EOF if you can get so many information from the EOF result? Please.
Now, regarding the EOF result, so it is clear that we can get so many informations from the EOF alone. We have so many principal components, but the pronounced percentage is only, I think, the first 3 or 4 principal components. So the 5, the 6, and so on is not holding so many percentage as the first principal components. So in addition to that, we have to accompany the analysis along with the frequency transformation and also the cross correlation. So the frequency correlation is more advanced. So because we can choose from the highest frequency, that is the Nyquist frequency, to the lowest frequency, that is the interannual seasonal or above interannual, maybe interdecadal periodicity. So we can clearly see that it is both compatible and yeah, it's worth it to do the spatial transforming function, as we can slice the frequency of interest. So yeah, that's the answer.
Okay, actually there is one more question from Raden, but I think you can address that in the chat room because the time is very limited. We have still 2 presenter. Now we move forward to the next presenter, Putri Dia Utari from LIPI. She will have presentation about observed of equatorial current in the Indonesian Ocean during two contrasting IOD event, 2006 and 2010. Please, Putri, are you there?
Yes, I'm here, sir.
Okay, maybe the video can be play over.
Okay.
Putri will present live.
Assalamualaikum warahmatullahi wabarakatuh.
Would you
First
see?
of all, I
Right?
will.
Okay, yes, yeah.
Wait. Could you hear the video, sir?
Yeah. Just continue.
Wait.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to all participants in here because giving me chance for presenting my research about observe of equatorial currents in the Indian Ocean dipole during two contrasting IOD events, 2006 and 2010. Before I explain more about this research, it will be better for me to introduce myself first. My name is Putri Adia Utari and I'm from Center of Deep Sea Research, Ambon. Today, I would like to explain the outline starting from introduction, why I choose this topic, and then what is Indian Ocean dipole events and how is the impacts of IOD events and the data and
The video is stopped.
Sorry, sir. There is a connection problem because I'm in Ambon. I think I'm not sure the connection is good in here at this time.
So the committee does not have your video.
Yeah. I already sent the video to the committee.
Okay, then the committee can play over the video, please.
Yeah.
Otherwise, we can move to the next speaker, and then we put Putri in the end of this season. Is that okay?
Wait. Okay.
to predict the presence of Indian Ocean dipole events, even positive Indian Ocean dipole or negative Indian Ocean dipole. And what is the characteristic of both IOD types? I will answer in the next slides. What is Indian Ocean dipole events? Indian Ocean dipole events is characterized by anomalous cooling of SST in the southeastern equatorial Indian Ocean and anomalous warming of sea surface temperature or SST in the western equatorial Indian Oceans. In the figure A show the normal condition. The westerly wind blew to the is to the eastern part of Indian Ocean, but the IOD condition happen in the opposite condition, like in shown in figure B, and the positive. And here I list the positive IOD year and negative IOD year, but I choose the positive IOD years in 2006 and the negative IOD years in 2010. Next, the impact of IOD events. I show the positive IOD events show that the easterly winds are dominant in the equatorial of Eastern Indian Ocean, and warm SST in the Western Indian Ocean, and the westward currents are dominant in the Eastern Indian Ocean, and also high rainfall in the Western Indian Ocean is really significant. Different with the negative Indian Ocean dipole, westerly winds are dominant and warm SST in the Eastern Indian Ocean, and eastward currents are dominant. Want to know if we want to know there is anomaly condition in ocean or atmospheric circulation, we need to calculate the climatology. Here I provide the climatology equation that I use to determine that I applied. If we want to know if we want to know there is anomaly condition in the ocean atmospheric circulation in Indian Ocean, we need to calculate the climatology equation and the anomaly equations, and here I provides the climatology equation and anomaly equation in the below. And next, this is the data that I use in this study, starting from surface winds. I use from the HMWF, and then surface currents, current data of ADCP, sea surface height, and dipole mode index. And next, this is the results about the ocean circulation in 2006. Starting from dipole mode index, show that the evolution of positive IOD in 2006 took a peak phase starting from August starting from August till November of 2006, and how the condition the surface current anomaly at 80.5 degrees and at 90 degrees. In this surface current, we can see a significance of the evolution of the positive Indian Ocean dipole. But in the zonal current anomalies, we can see clearly the strong eastward current anomalies found in the boreal spring starting from March until May, in the beginning of May, and the westward current anomalies in boreal fall observed quiet height above thermocline at 80.5 degrees, but both the 80.5 and 90 degrees at surface current anomalies didn't show significant signal which is related to the evolution positive IOD events. And how is the evolution of negative Indian Ocean dipole in 2010? The dipole multi-index or DMI show the significant of negative IOD evolution starting from boreal fall September till November, and same like the surface current in 2006. The surface current in 2010 at 80.5 degrees and 90 degrees didn't show significance, but significance evolution of dipole Indian Ocean negative Indian Ocean dipole, but in the zonal current and the zone but in the zonal current at 80.5 and at 80 degree and 90 degrees show the eastward current anomalies, and also the intraseasonal perturbation were found at the depth 40 meters till 180 meters in boreal fall. Next, how about in the westerly wind anomaly, sea surface height anomaly, and surface currents? In this part, we can see the strong easterly observed at the surface current, which was occur in boreal fall. September until December, and it really long as long as sea surface height anomaly, which is a strong negative SSH anomaly in a region east and large positive anomalies to the west between September to the December, and the strong westward anomaly were significant in January until April 2006 and July 2006 associated with easterly winds. How about the 2010? The strong westerly observed at surface currents, which was occur in boreal fall September until November, and the strong positive SSH anomaly in a region east and large negative anomalies to the west between September to December, and the eastward were significant whole of the year 2010 to westward, and do westward detected in February until March 2010. So the conclusion of this Indian Ocean in this contrasting IOD events is first the DMI evolution point out that the positive IOD was strong in boreal fall than boreal spring during 2006. Contrasting with a year in 2010 showed the negative IOD evolution in boreal fall. Both positive and the second, both positive in 2006 and negative IOD 2010 didn't show the correlation between surface and subsurface condition. And the last, the evolution of DMI in 2010 was weak due to intra-seasonal perturbation at the subsurface. And this is the last of my presentation today. Thank you very much for your attention, and sorry if I have a mistake to present in my presenting today.
Yeah. Okay. Thank you very much for Putri. Give applause to her. And so far, I don't see any question in the chat room. Is there any question from the floor? Otherwise, we will continue to the next speaker, because we are run out of time now. Almost 10 minutes to 5. Okay, I think no questions. Yeah, we continue to the last speaker, that is from Rahadin Bagas Hatmaja. He will present the linkage between the Indian Ocean dipole asymmetry and Southwestern Indian Ocean upwelling. Pak Rahaden, are you there, Mas Rahaden?
Yes, sir.
Okay.
I already sent the video.
Okay, then the technical support can play the video, please.
Good afternoon. I am Rahaden Bagasatmaja. I'm from Center of Atmospheric Sciences and Technology, National Institute of Aeronautics and Space, or LAPAN, Indonesia. Today, I would like to present my research about linkage between Indian Ocean dipole asymmetry and Southeastern Indian Ocean upwelling. So, first of all, the Southeastern Indian Ocean upwelling, or we usually call Java upwelling, is a seasonal upwelling in Indian Ocean, which is generated by the southeast monsoon wind from Australia along the coast of Java to Sumatra, and it will terminate in December to February due to the cause of northwest monsoon and the prevailing Kelvin wave. On interannual timescale, earlier studies argued that the interannual variability of the Southeastern Indian Ocean upwelling, or Java upwelling, is closely related to ENSO. It is due to the oceanic bridge between the southern waters of Java and the Pacific Ocean through Indonesia through flow, or ITF, and as well as the atmospheric bridge that affect the easterly wind anomaly. During El Nino, ITF transport cooler water, thus reduce the thermocline depth and strengthen upwelling, and vice versa during the La Nina. The recent study showed there is a significant correlation between wind stress and the DMI index compared to the Nino 3 index. It means that there is a dominant contribution of IOD on interannual variability of thermocline depth as an indicator of Java-Sumatra upwelling through remote equatorial forcing generated by the easterly wind anomaly at the equator, or Kelvin wave. Furthermore, about the IOD has an asymmetric characteristic, which is defined as the difference in the amplitude of IOD-related parameter anomalies, such as sea surface temperature, wind, and sea surface height, and so on, that occurs between one phase and another. As we can see here, that during the independent IOD event, the amplitude of sea surface temperature anomaly is much greater in the Eastern Indian Ocean, or the cold anomaly is greater. Compared to the IOD event that occurred El Nino or ENSO, the greater amplitude is shown in the Western Indian Ocean. The linkage between Java upwelling and IOD asymmetry that is independent on ENSO phase is not clear. Therefore, this issue is investigated in this research, or in this study, based on the analysis of Kelvin wave propagation, subsurface ocean dynamic, and thermocline depth, as well as chlorophyll A concentration as upwelling parameter associated with IOD asymmetry due to ENSO. This is the analysis domain, or area of the study. The red box is the domain of the equatorial Indian Ocean, and then the orange box is the region of the upwelling, or Java upwelling. And this red dashed line is the Kelvin wave guide along the equator to the coast of Sumatra to Java. The data used in this study are zonal and meridional wind, sea surface temperature, thermocline depth, sea surface height, and zonal currents, which are retrieved on ECMWF. And then we used the chlorophyll A concentration from Aquamodi satellite data. All data used are monthly means for 30 years from 1988 to 2017. So the impact of IOD asymmetry related to ENSO on Java upwelling characteristics was assessed based on composite analysis conducted on two positive IOD events that co-occurring with El Nino in 1997 and 2015. And we assessed with composite from three independent positive IOD events in 1994, 2006, and 2012. The methods we used in this study, from the monthly mean data, we validated it first with observation data, and then we calculated the anomaly based on 30 years climatology, and then the trend and low pass filter to get the interannual variability data and move out the trend. And then we did EOF analysis, composite analysis, and cross correlation analysis. Here we get the results and discussion. First is the asymmetric characteristic of sea surface temperature, zonal wind, and sea surface height anomaly during the IOD. From the EOF analysis, as we can see here, IOD is represented by the second mode contribution around 23.1%. And then we correlated temperature, zonal wind, and sea surface height to get the region that are significantly correlated to IOD to define multiple indices that can elucidate the characteristic of the IOD events. The indices are used from the SST dyne, which calculated from the sum of the half of the sum Western Indian Ocean and Central, subtracted with the mean of Eastern Indian Ocean. And then this is the region of the zonal wind, and this is the sea surface height dynamic calculated from the gradient between the Central Indian Ocean and Eastern Indian Ocean. So this is the evolution of the three indices that represent the Indian Ocean dynamics. It can be seen that during the PIOD-EN event, the SST anomaly is initiated in April, followed by the easterly winds and the sea surface height anomaly. After it peaks, the amplitude decreases and fully terminates in February in the following years, while the wind and the sea surface height terminate in April to May. Otherwise, during the PIOD event, the indices amplitude, tends to be weaker. You can see the amplitude is lower and reaching its peak in September to November. And the evolution also tends to be shorter, that terminates in December. From the pole of the sea surface temperature anomaly from the Western Indian Ocean and Eastern Indian Ocean, it can be seen that during the PIOD-EN event, or positive IOD which occurred with El Nino, the amplitude is much greater in the Western Indian Ocean compared to the Eastern Indian Ocean. In the EIO, or the eastern part, the greater amplitude is occurred during the PIOD event or the independent event. Next, we see the spatial distribution. As we can see here, anomalously warm SST is higher in the Western Indian Ocean during the PIOD-EN event. Moreover, the anomalous easterly winds is also stronger, thus generating the positive sea surface height anomaly westward. On the other hand, during the independent event or PIOD event, anomalously cold sea surface temperature in the Eastern Indian Ocean tends to be colder and widespread to the south of 15 degrees south due to the absence of ENSO, which typically influence atmospheric variation of our southern tropical Indian Ocean. So we move deep dive to the ocean. We can see here that during the PIOD event, anomalous easterly wind generated anomalous wind. Generated anomalous positive sea surface height at 45 degree east to 80 degree east in March, as well as anomalous negative sea surface height in the east of 80 degree east as upwelling Kelvin wave. Moreover, the anomalous easterly winds and sea surface height zonal gradient also damped the Wilkie jet, which represented by the surface zonal current here, and then consequently decreased the thermocline depth over the Eastern Indian Ocean and conversely over the Western Indian Ocean. The zonal gradient of this thermocline depth across the basin generates the equatorial undercurrent that represented by the subsurface zonal current here. And this undercurrent also support the steepening of Java upwelling. And then during the IODEN event, due to its longer and stronger evolution, anomalous easterly winds blow longer and stronger up to 55 degree. And then how about the dynamic of the upwelling due to its IOD asymmetry? So from this figure, we can see that D20 dyne and CHR dyne respectively are representing a thermocline depth and chlorophyll A concentration average of this area. And we can see from this figure that our longer and stronger evolution of the IOD event results in shallower thermocline depth, which is also earlier and more persistent than during the IOD event. And otherwise, the chlorophyll concentration during the independent event is much higher. It is suggested that this is a result of widespread of cold SST due to the absence of El Nino and also westerly cyclonic eddies that increase nutrient concentration in the euphotic zone. And then this is the spatial distribution, which also confirm the graphic. And then this is the conclusion. During the PIOD event, easterly winds anomaly generate zonal sea surface heat anomaly across the Indian Ocean, followed by the upwelling Kelvin wave propagation along the equator, and also damped the Whitney jet. Consequently, in the southeastern Indian Ocean, the shallow thermocline depth straightened the upwelling. And then during the PIODEN event, equatorial zonal wind blows longer and stronger, resulting in earlier and more persistent shallowing of the thermocline depth. Even though the upwelling is stronger, the chlorophyll A concentration during the PIOD event is much higher, with a peak up to 3.19 standard deviation. It is suggested that this is the result of the widespread of the cold SST. Okay, that's all my presentation. Thank you for your attention. Good afternoon.
Thank you very much. We already 5:02, but I think this is a nice presentation. Big applause to the presenter. Any question from the floor? I don't see any. Otherwise, I have one question regarding that the iodine and Wikijet. You say that in the independent IOD, the Wikijet dumped and then make such thing in the eastern part of Indian Ocean. And what happened to the Wikijet during the couple El Nino and IOD event, positive event?
Yes, thank you for the question. When the sorry, when the characteristic same as well, with because of the stronger wind during the PIOD and so the wind jet more westward, so the speed of the wind jet is decreased. I think that's all for the answer.
Wind is what or westward? Wind is what or westward?
I mean, wind jet move eastward. Yeah, eastward. And then because of the wind, due to the wind, and when the PIOD co-current with, and so the wind blows stronger, right? And then the anomaly become westward. The anomaly. So it's not means the wind jet move westward, but the represent the westward movement like that.
Okay. There is one question from Lamona Bernalis. I think you can answer that directly in the chat room, because we already 5:04, and actually we already the time is already over since 10 minutes ago. But due to the very nice and interactive discussion in some part of this session, we have the session in this time. I congratulate to all presenters that already presented their research results. Congratulations, and this is very good chance for your research opportunities in the future as well. And if we don't mind, I invited Bu Yvonne or Pak Dr. Agus Santoso to give a close statement or comment to this session, if it is possible. Bu Yvonne or Dr. Agus, otherwise we can close the session.
I think it's better Pak Agus because he's a guest our Pak Agus, Agus Santoso.
Okay, please Pak Dr. Agus Santoso to give a comment for this session. Please.
Thank you, Pak Siswanto, for very nice moderating the session, and thank you for all participants for presenting and listening to our presentations. I think this research in IoT in particular is very interesting, and there's lots of research questions that are yet to be resolved. Yeah, so I think for the next year or so, it will be interesting. Also, we need to look at what's happening in the Indian Ocean right now. It's warming up, and this year there seems to be a development for a negative IoT. So I think it's interesting, and keep up the good work, everyone. And thank you, Bu Yvonne, for inviting me to participate in this event. So thanks very much, everyone.
Okay, thank you, Pak Agus. Thank you, Bu Yvonne, and thank you for all participants who make the session successful. And now we close the session. I give the session to the Master of Ceremony. Thank you very much. Very good evening and very good afternoon and good evening for all of us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Pak Siswanto, to be being our moderator. Thank you, Pak Agus Santoso from the committee, and thank you to all the participants who joined this session. I think there's still a lot of people in here in this room.
Yeah.
Thank you.
Thank you, Bu Yvonne.
Sama-sama Pak Siswanto. Terima kasih buat Bapak Ibu sekalian yang hadir. Ibu guru juga yang bisa mungkin ikut bergabung juga mendapatkan ilmu yang baru, Bu ya.
Ibu perlu foto bersama nggak, Bu?
Iya boleh. Ibu-ibu bisa dibuka kameranya, kita akan foto bersama.
Mungkin nanti perlu untuk pembuktian.
Bu Mona mau potret, Bu Mona?
Boleh, sebentar ya. Berarti view-nya harus diganti.
Silakan.
Apa habis ini perlu ke main session lagi atau
nanti ya kita akan pindah ke main session, kemudian ada pengumuman sebentar dan langsung selesai.
Oke. Tapi yang buka kamera cuma sedikit nggak apa-apa ya. Jadi kita butuh 3 kali foto ini. Mungkin nanti diminta oleh publisher, saya khawatir. Baik. Terima kasih Bapak Ibu, kita foto sebentar, ada 3 halaman, berarti 3 kali foto ya. 1, 2, 3. Sebentar. Halaman kedua. 1, 2, 3. Halaman ketiga. 1, 2, 3. Thank you everyone. Thank you very much.
Terima kasih Bu Mona.
Semuanya, sampai bertemu. Kita akan masuk ke room main room lagi ya. Kita akan masuk ke main room lagi. Kita akan masuk kalau sudah selesai. Terima kasih. Ternyata banyak ininya juga ya, peminatnya yang tentang IoT dan ini. Enso, Pak Agus.
Ya, Bu.
Ini apa tentang ENSO dan IoT ini termasuk yang banyak yang presenternya juga banyak, Pak ya.
Iya.
Karena sangat related dengan daerah kami sebenarnya, daerah Indonesia.